Dear student, welcome to ACE Online, digital platform of ACE Engineering Academy. Myself, Dr. G. Balaraju, Professor of Mechanical Engineering. In the present video, we are going to discuss the detailed solutions for Pre-GATE 2026 is being organized by ACE Engineering Academy. So why this exam is being organized by ACE Engineering Academy? The main motto is, it is just simply a GATE 2026 model. So once you complete this examination, you can understand. So where you had a mistake, those mistakes you should not repeat. And coming to this pre-GATE 2026, we set question papers such a way that PYQs, previous year question papers, once you see the previous year question papers, 2021 to 25. So we had 3 streams, right? Production, design, thermal. So each stream around 24 marks you can expect. Mathematics fixed 13 marks, aptitude 15 marks. So out of 100, so from production 24 to 25, design 24 to 25, thermal also 24 to 25, and mathematics. Just see this a particular analysis. This slide will give the clarity. So from where we are getting questions and coming to the details. Once you see the details, so just let us have production. Suppose when you are preparing for production, just keep in mind which subject you are focusing. So where you can get maximum marks. So don't go without this. So when you are taking production stream subjects, you must have this table. So at least for that sake, we are presenting here. Just you can make use of this particular slide. So those who are preparing for production, particularly when you are taking production stream, I am talking about GATE mechanical, under GATE mechanical production stream. So production, it could be casting, metal casting, welding, metal forming, advanced machining methods, and even SIM, machine tools and metal cutting, metrology. All together 18, 15, 12, 15, 16. So around 15 to 16 marks you are going to get from metal casting, welding, forming, metrology, sheet metal, SIM, metal cutting science. And coming to IM and OR, 6 to 8 marks. From material science, 1 mark. In 2023, only we had 5 marks. The remaining papers, only 1 mark. So out of 25, you plan for 12, 50% at least, in order to score 50 marks in GATE 2026. So from production, what is your target? At least you have to get 12 marks. So like how to get 12 marks? Just think over. From IM and OR, at least 4 marks. From metal cutting science and machine tools, 3 marks. From advanced machining methods or maybe metrology, 2 marks. Like that you plan, maybe metal casting, 2 marks. From production, you have to get 12 marks, worst case. And coming to design, in design stream, so this slide will be helpful to you. Okay, from the design stream, where you are getting maximum marks and where you are getting less marks. And subject wise, we have analyzed. See, engineering mechanics, 2 to 4 marks. So definitely you can find one question from engineering mechanics. Strength of materials, the weightage is really good enough, 6 to 7 marks. Strength of materials, very, very important subject. And machine design, it could be 6 marks. From theory of machines, 8 to 10 marks. Suppose you are not good at vibrations, dynamics of machinery as with theory of machines. Particularly when you are not sure about theory of machines, don't worry, at least you plan for 50% in this. So design, your aim should be at least 12 marks you have to score. Plan like that. Whether you are getting more score from SOM or machine design or theory of machine, that is up to you. So how to get 12 marks? Just plan. Okay, this slide will be helpful to you for planning your strategy. And coming to thermal engineering, basic thermodynamics, applied thermodynamics, heat transfer, fluid mechanics and turbo machinery. Now see the weightage. So in thermodynamics, we may be getting 10 marks around. In heat transfer, 6 to 7 marks. From fluid mechanics and turbo machinery, 10 marks, 8 to 10 marks where we can expect from fluid mechanics and turbo machinery. Again, you can plan for 12 marks in thermal engineering. So what is the strategy you can design? Thermal, design, production, 36 marks. Mathematics, maybe 6 marks, maybe 7 marks. 36 and 7 or maybe 36 and 7, 43. And aptitude, you try to get at least 10 marks. So 50 plus you are going to get. So in order to score 50 plus, what is required? Just have a strategy. Like this you can prepare.
Okay, now coming to mathematics questions. See, if A and B are 2 by 2 matrices such that determinant of B is 8 and A cube is equal to B square. Determinant of B given, A cube is equal to B square. Then the determinant of that new matrix required. See, first A cube is given as B square or not? Given A cube is equal to B square. Take determinant on both sides. What it is? Determinant of A cube is equal to determinant of B square. So, inside power and outside power both are same. Determinant of A whole power m, det A power m both are same already you know. So, that I will write it as det A cube is equal to determinant of B square. Already determinant of B given as 8 or not? So, det A cube is equal to 8 square is nothing but 64 or not? Det A cube is 64 means what is determinant of A? Determinant of A is 4. Okay, det A is 4. Now, actual question is determinant of 3 A transpose. What is the question now? Determinant of 3 A transpose B A inverse B inverse A na? Yes. So, it is in a form determinant of Ka. What is determinant of some Ka? It's complete, you can take it as a matrix. Okay, determinant of some Ka is nothing but K power n into det A or not? What is an order? Order is a 2 by 2. So, that this is 3 square into determinant of A transpose B A inverse B inverse A. Is it? Now, that is 9 into determinant of AB is nothing but det A into det B or not? You can take the separate products. So, determinant of A transpose into determinant of B into determinant of A inverse into determinant of B inverse into determinant of A. Det A inverse and det A both are cancelled. Det B and det B inverse both are cancelled. 9 into determinant of A transpose. Det A and det A transpose both are same. Determinant of A already this is 4 in the sense. So, determinant of A transpose is also 4. Answer is 30. Which option? Option A is correct. Clear? Coming to the next problem. If capital X is a continuous random variable with PDF, probability density function given like this, P of 1 less than X means what is the meaning? Probability of P of 1 less than X required. That is nothing but P of X greater than 1 or not. Okay, probability after 1 less than X means X is greater than 1. Probability after 1 means up to infinity or not. That is nothing but integral 1 to infinity. Okay, f of x dx. To find the probability, it is enough to integrate the probability density function, you know, between the given limits. So, 1 to infinity, what is f of x? That is nothing but e power after, see, 0 less than, say, this is e power minus x given. So, function is e power minus x dx. So, that is nothing but e power minus x by minus 1. Limits are from 1 to infinity. So, minus you can take common, e power minus infinity minus e power minus 1, that is minus of e power minus infinity is 0, e power minus 1 is nothing but 1 by e. Final answer is 1 by e. Is it? This is clear? Now, coming to the next problem. 1 by e is the answer. 1 root of the equation 3x minus 1 minus cos x lies in the interval. Okay, so apply intermediate value theorem, already options given. Okay, see, this is numerical methods problem. If f of a already you know intermediate value theorem, if f of a and f of b both are having opposite signs, the root lies between a and b. So, which interval is giving the opposite signs, you can take that as a interval. That is f of x is nothing but, you can take the function as 3x minus 1 minus cos x. So, first you instead of verifying option wise, better substitution of 0 and pi by 2 is easy for me. So, that I will substitute option B first, means I will verify f of 0 and f of pi by 2 first. Luckily, if f of 0 and f of pi by 2 both are having opposite signs, that would be our option. So, remaining options no need to think. Okay, suppose if option B is ruled out, suppose if option B is wrong, then I have to verify the remaining options. Substitution of 0 and pi by 2 is easy for me, so that I will verify this option first. What is f of 0? F of 0 is nothing but, so minus 1, cos 0 is also, this is 0, minus 1, cos 0 is minus 1, so minus 2, less than 0, negative. What is f of 1? F of 1, sorry, f of pi by 2, na? F of pi by 2. What is f of pi by 2? F of pi by 2 is nothing but, so 3 pi by 2 minus 1 minus cos pi by 2 is 0 or not? Very clear. 3 pi by 2 value, pi value is 3.14, 3.14 by 2, 3 into pi by 2 minus 1, obviously positive value only, that is greater than 0, value is not a criteria. So, positive or negative is sufficient. F of 0 negative, f of 1 positive means, therefore by intermediate value theorem, root lies between, so f of 0 negative, f of pi by 2 positive. So, by intermediate value theorem, the root lies between 0 and pi by 2. Therefore, the root lies between 0 and pi by 2. So, which option? Option B correct. Clear? Coming to the next problem. Say this. 4x cube minus 8x square plus 24x plus 7. The one function given, maxima and minima we need to identify. First, find first derivative and find stationary points, and then you can substitute in second derivatives. Which option is correct, we will verify later. So, what is f of x? Here function f of x is given as 4x cube, what it is, minus 18x square plus 24x plus 7 plus 7. F dash of x is nothing but 12x square minus 36x plus 24 is f dash of x. What is f double dash of x? 24x minus 36. F double dash of, put f dash of x is equal to 0. Okay, because I have to find stationary points first or not. So, that is nothing but 12x square minus 36x plus 24 is equal to 0. Better you can take 6 common. 6 are directly 12 will cancel. Why 6? X square minus 3x plus 2. X square minus 3x plus 2 is equal to 0. That implies x minus 1 into x minus 2 is equal to 0 or not? That implies x is equal to 1, 2 are stationary points. Okay. So, substitute 1 in double derivative, substitute 2 in double derivative. Now, at x is equal to 1, what is f double dash of 1? So, double derivative is nothing but 24 into 1 minus 36 means minus 12 or not? Minus 12 less than 0. If double derivative is less than 0 means function has, so double derivative less than 0 means that gives a point of, see, function gives the maximum value, local maximum value at x is equal to 1. That implies x is equal to 1 is a local point of maxima, and the maximum value is, maximum value means local maximum value is f of 1. What is f of 1 value? Substitute 4 minus 18 plus 24 plus 7. 4 minus 18 plus 24 plus 7. Yes. So, 4 plus 24, 4 minus 18 minus 14, minus 14 plus 24 is 10, 10 plus 7, 17. Next, f double dash of at x is equal to, another point, x is equal to 2. What is f double dash of 2? Double derivative at 2, that one. So 24 into 48 minus 36, it is 12. Greater than 0. Double derivative greater than 0 means, is it a local point of minimum or not? That implies x is equal to is a local point of minimum. And the minimum value is, minimum means local minimum value. Minimum value is f of 2. Substitute 2 means 2 cube is 8, 4 8s are 32, minus 18 4s 72. Is it correct? Yes, 18 4 72, 24 2s 48 plus 7. So 32 minus 72 means minus 40. Okay, minus 40 plus 48 means 8, 8 plus 7, 15. F of 1 local, say which option, x is equal to 1 is a point of minima. Wrong. X is equal to 1 is a local point of maximum. Option A, wrong. X is equal to is a point of maximum. Wrong. Maximum value of the function is f of 1 at 17. Correct. The minimum value of the function is f of 2 at 15. That is correct. F of 2, minimum value is f of 1, that is 17. Sorry. Maximum value is f of 1, that is 17. Minimum value is f of 2, that is 15. Minimum 15, maximum 7. So option C, D are correct. Clear? Option C and D are correct for it. Now coming to the next problem. For the following partial differential equation on PDE given to you like this. Here, see nature of the means type of the second order linear PDE, is it parabolic or hyperbolic? We have to verify. So what is B here? You see, we have to compare. What is A here? A is equal to x. B is nothing but B is 0. What is B? Dou square u by dou x square coefficient is A, that is x. Dou square u by dou x dou y coefficient is B, but dou square u by dou x dou y coefficient is missing. That term is not there. So B is 0. So B is 0. What is C? C is equal to minus y. Is it right or not? C is equal to minus y here. What is B square minus 4AC value? B square is 0. Minus 4 into A is x, C is minus y. That is finally 4xy. Finally 4xy. Now here different cases will arise. What is the first case? Suppose if x greater than 0, y greater than 0. If x and y both are positive, we will verify all the cases. Which option is correct? We will verify later. So if both x and y both are positive means 4 into product of two positive values is also positive. Okay, R. Not only that, R. X less than 0 and y also less than 0. Suppose if x and y both are positive, product is positive. Suppose if both are negative also, negative into negative also positive. In both cases, okay, that is b square minus 4ac greater than 0. If b square minus 4ac greater than 0, that PDE is hyperbolic or not? Yes, PDE is hyperbolic. Understood? Okay, next 2. Second case, if x is equal to 0 or y is equal to 0 or both x is equal to 0 and y is equal to 0, minimum, if at least one of them is 0, then what will happen? If at least one of them is 0 or both are, means if at least one of them is 0 means either x 0 or y 0 or both 0. So b square minus 4ac becomes 0. B square minus 4ac is equal to 0. That implies PDE is parabolic. Clear or not? Third one. If x is equal to, if one is positive and one is negative, then what will happen? If x greater than 0 and y less than 0, or x less than 0 and y greater than 0. If one is positive and one is negative, positive into negative means negative only, negative dominates. Then what will happen? B square minus 4ac less than 0. Less than 0 means that implies PD is elliptic. Now, which option is correct? You verify. Hyperbolic, yes, it is wrong. Okay, hyperbolic in which case? If both are positive or both are negative, that only hyperbolic. Hyperbolic, yes. If both are positive, hyperbolic. Parabolic means what? If at least one of them is 0, then only it is parabolic. Elliptic. If one positive, one negative means total negative dominates, elliptic is right. So, options B, comma D are correct. Understood? Next, you see this is Gauss divergence theorem application. The value of integral, double integral of, okay, means surface integral of f bar dot n bar ds, where S is the surface of the sphere having a center. So, we have to find the surface integral over the spherical surface. Okay, over the spherical surface, what is f? F is given like this. So, by divergence theorem, you can apply divergence theorem here. By divergence theorem is Gauss divergence theorem. By divergence theorem, what it is? Surface integral of f bar dot n bar ds is equal to volume integral of divergence of f bar dv or not. So, first what is divergence of f bar? So, this is f bar is nothing but this is f1i bar plus f2j bar plus f3k bar or not. That is f bar. What is divergence of f bar? Divergence of small f or capital F? What it is? Dou by dou x of f1 plus dou by dou y of f2 plus dou by dou z of f3 already. f1 with respect to x, that is 2 only. f2 with respect to y, 1 only. Here minus is there, so minus 1. f3 with respect to z, 2. This is 3. So, this is surface integral of f bar dot n bar ds is equal to triple integral of divergence of f means 3 dv. That is 3 into triple integral of dv means is it volume of a sphere or not? 3 into volume of a sphere. Three into what is volume of a sphere? 4/3 pi r cube. Is it? But what is r here? 3 will cancel. What is r here? R is nothing but the radius is given as 3. That is 4 pi into 3 cube. Is it? 3 cube is 27. 4 27. 108. 108 pi. 108 pi is an answer. Is it? Clear? Coming to the next problem. General solution of the differential equation x square into d square by d square minus 4x into dy by dx plus 6y is equal to 42 by x power 4. You see this? This is in a form x square d square. xd means coefficient of d square is x square, coefficient of d is x, means this is Cauchy-Euler linear d. That too non-homogeneous. Okay, given d, you can write like this. This I am writing as x square d square minus 4xd plus 6 into y is equal to 42 by x power 4. Clear or not? Is it Cauchy-Euler linear d or not? This is Cauchy-Euler linear d. How to solve Cauchy-Euler linear d? Put z is equal to log x is equal to, generally e power z is equal to log x or not? X is equal to e power z. That implies z is equal to log x. From this, you know, xd will become theta. X square d square is nothing but theta into theta minus 1. Reason how xd will become theta, x square d square is theta into theta minus 1, already you know the reason. Okay, so substitute in 1, let it be 1. 1 implies, I am substituting here. 1 implies what it is, x square d square is theta into theta minus 1 or not? Theta into theta minus 1 minus 4 theta plus 6. into y is equal to 42 by x to the power 4. X is e power z. X to the power 4 is nothing but what it is? E power 4z or not? That is 42 e power minus 4z. Okay. So this is non-homogeneous linear differential equation, that to type 1 model. Okay. Non-homogeneous linear DE, that is type 1 model. So auxiliary, I will write one more step. Theta square minus theta minus 4 theta minus 5 theta plus 6 into y is equal to 42 e power minus 4z or not. Okay. Now auxiliary equation. What is AE? Auxiliary equation is theta square minus 5 theta plus 6 is equal to 0. That implies theta is equal to 2, theta is equal to theta square minus 5 theta plus 6 is equal to 0. Theta is equal to 2, 3 are the roots. This is auxiliary equation. Now, complementary function CF is YC is equal to C1 e power 2z plus C2 e power 3z. C1 e power 2z. E power 2z is nothing but x square or not? Because e power z is x means e power 2z is x square. C1 x square plus, because finally you have to write in terms of x. C2 x cube. Now pi is particular integral. This is type 1 model. E power ax model. It is type 1 model, you see. 4z. Pi is means particular integral is yp is equal to what it is? 4 e power 42 e power, e written by mistake. This is 42 na. 42 e power minus 4z by what it is? Theta square minus 5 theta plus 6. Theta square minus 5 theta plus 6 means in place of theta I have to substitute minus 4 or not. What is f of theta? F of theta is theta square minus 5 theta plus 6. Plus 6. Okay, so f of minus 4 you substitute. So f of minus 4 is nothing but that is 16 plus 20 plus 6. Correct or not? 16 plus 20 plus 6. Okay, that is 42 na? This is also 42. So this is f of theta. F of minus 4. So that is nothing but 42 e power minus 4z by 42. 42 both will cancel. That implies yp is equal to e power minus 4z. E power z is x. E power minus z is nothing but 1 by x or not? That is 1 by x power 4. Okay, this is x power minus 4 is e power. So is it 1 by x power 4 or not? So therefore, general solution is because say this, x is e power z. E power 4z means that is x power 4. E power minus 4z means 1 by x power 4 or not? General solution is y of x is equal to yc plus yp. What is yc? C1 x square plus C2 x cube plus 1 by x power 4 is an answer. Clear? Any option is? Okay. No option is here. Yes. C1 x square plus C2 x cube plus 1 by x power 4. Option D is there here. Clear? You say this. Consider the following matrix. If all eigenvalues of a matrix are same, one matrix given 3 by 3 matrix, all its eigenvalues are same given, but we don't know what they are, but not required. All eigenvalues are same means let it be lambda, because it is a 3 by 3 matrix. You can take 3 eigenvalues. Those 3 eigenvalues are lambdas only. let lambda is an eigenvalue of A. Since all three eigenvalues are same, therefore eigenvalues are lambda, lambda, lambda. We have sum of the eigenvalues is equal to trace or not? Yes. Already you know sum of the eigenvalues is equal to trace. We have sum of eigenvalues means that is lambda plus lambda plus lambda is equal to trace. That implies 3 lambda is equal to what is trace? 6 plus 4. 10 minus 13 is minus 3 or not? Trace. 6 plus 4, 10. 10 minus 13, minus 3. So, that implies lambda is equal to minus 4. Yes. Now, product of eigen, already I know the eigenvalue. Product of eigenvalues is equal to determinant or not? Yes. Product of eigenvalues. Now, we have one more step. Product of eigenvalues. That is lambda into lambda into lambda is equal to determinant of A. Lambda is nothing but minus 1 or not? So, minus 1 into minus 1 into minus 1 is equal to determinant. Determinant is nothing but, you know how to find, that is 6 into minor. What is minor? 4 13s, 52, minus 52 plus 60. Minus 52 plus 60. Clear? 6 into minus 52 plus 60. Minus of minus plus 6 into this one. Plus 6 into, delete this row and column. 4 14s are 56 minus 10x. 56 minus 10x. Plus 5 into what it is? Minus 4, 6 14s. 84, minus 84 plus 13x. Clear? Minus 1 is equal to, clear or not? Minus last row, that is minus 84 13 plus 13x. Yes, right. Minus 1. This is 8. 8 6 are nothing but 48. 56 plus 336 minus 60x plus minus 584 minus 420 plus 65x. Clear? That implies minus 1 is equal to 48 plus 336. 330 plus 40, 370. 378 plus 6, 380. 376 plus, 378 plus 6 means 384 or not? 384 means here 20 is minus 26. Minus 26, minus 36. Clear? Minus 36 plus 5x plus 5x. That implies 35 is equal to 5x. Therefore, x is equal to 7. Is it clear or not? X is equal to 7. Okay? Next problem. Forward Euler's method is used to find the numerical solution y1 at x is equal to 0.2 with h is equal to initial value problem. Y of 0 is equal to 1. What is the magnitude of y of 0.2 minus y1 approximately? Means what is the meaning? Y of 0, initial value given. So, differential equation given, initial value at 0, output is given as 1. So, Forward Euler's method is used to find the numerical solution y1. So, to find the next iteration y1, forward Euler's method is used. Means to find y1, you can use forward Euler's method, but by solving the differential equation directly, you can find y of 0.2. Same, y1 is nothing but y of 0.2 only. Simply what they are asking, find y of 0.2 by using y1 is nothing but at 1.2 step. After 0.2 gap, they are asking y1. So, find y of 0.2, they named as y1 using forward Euler's method, and same y of 0.2 by using direct solution of the differential equation. This is the exact value, this is the approximate value. What is the magnitude? Simply absolute error they are asking. So, first you solve it directly. What is given? The given differential equation is dy by dx is equal to minus 2xy square. As it. So, this is nothing but minus 2xy square means that implies, okay, this is in variable separable form I think. Dy by y square is equal to minus 2x dx or not? Dy by y square is equal to minus 2x dx. Okay. Integration of 1 by y square is nothing but minus 1 by y. So, minus 1 by y is equal to minus 2x square by 2 plus 2 will cancel. Minus 1 by y is equal to minus x square plus c. Is it? Minus 1 by y is equal to minus x square plus c. Now, condition given, let it be 1. What is the given condition? Given y of 0 is equal to 1 or not? Given y of 0 is equal to 1. 1 implies input 0, output 1. Input 0 means in place of x, substitute 0, in place of y, 1. So, that is nothing but minus 1. If I substitute 1 here, minus 1 by 1 is 1, minus 1. This is 0 plus c. That implies c value minus 1 or not? So, minus 1 by y, that implies from 1 implies minus 1 by y is equal to what it is? Minus x square minus 1. Minus x square minus 1. That implies what is y? So, 1 by y is equal to 1 plus x square. That implies y is equal to 1 upon 1 plus x square. Therefore, y is a function of x. Y of x is equal to 1 by 1 plus x square. Now, what they are asking? Y of 0.2. Y of 0.2 is nothing but 1 by 1 plus 0.2 whole square. That is 1 by 1 plus 0.04. That value what it is? You verify. Actually, I have verified 1 minute. Just I have verified and written here. That is okay, or else better you can. I will verify parallelly. 0.9615 this value. Sorry, this value is 0.961. This is exact value. Now we can find approximate value also. Now by Euler's method, approximate value by Euler's method. By forward Euler's method. What is the function here? So, dy by dx is equal to, it is f of xy form or not? This is f of xy. To apply forward Euler's method, what is f of xy here? Here, f of xy function is nothing but minus 2xy square. Initial conditions given, what it is? Given y of 0 is equal to 1. So, this is a function f of xy is nothing but here initial given y of 0 is equal to 1. Y of 0 is equal to 1 means here input x naught is 0, y naught is equal to 1. At step size, what is the step size? Step size is 0.2. H is given as 0.2. Y of 0.2 required, that is a question mark. Means that is required to me. X1 is 0.2. Y1 required to me. Y1 is a question mark. Is it? Y1 is required. By forward Euler's method, what is the formula? By forward Euler's method, y1 is equal to y naught plus h into f of x naught y naught. So, what is y naught? Y naught is given as 1 or not? 1 plus h is 0.2. What is f of xy? F of xy is minus 2xy square. F of x naught y naught minus 2x naught y naught square or not? That is 1 minus 0.2 into 2 into that minus written outside. What is x naught? X naught is 0. Y naught is 1 square. What it is? 1 minus, this is simply 1 only. Y1 is 1. Therefore, this is y. See, what is our question? Modulus of y of 0.2 minus y1. Now, actual question is, this is approximate value, this is exact value. Modulus of y of 0.2 minus y1. That is nothing but 0.9615 minus 0.9615 minus 9615 minus 1. What is this value? Already I have verified, but I will write that value. What it is? 0.3085. Check it you also once. Is it? Okay. See, this problem is related to Cauchy integral formula in complex variables. Integral C z square minus 2z by z plus 1 whole square into z square plus 9 dz, where C is a circle. What we have to integrate around the circle. What is the circle? Okay, mod z is equal to means center 0, radius 2 or not? One rough circle I am drawing, center 0, radius 2. Okay, this is 2, this side minus 2, 2y minus 2y. What are the singular points here? So, singular points are nothing but z is equal to z plus 1 whole square means z plus I into z minus I or not. This is nothing but z plus 1 whole square. Z is equal to minus 1 repeated twice. So, z is equal to z is equal to minus 1, 2 times repeated, z is equal to z plus 1 whole square. Z plus 1 whole square means z is equal to minus 1, 2 times repeated. Next, z square plus 9. Z square plus 9 means z is equal to 1 is plus 3a and second one is minus 3a. Here, singular points are, what are singular points? Singular points are nothing but z is equal to minus 1 repeated twice, minus 1. Next, plus or minus 3i. Okay, one is plus 3i and second one is minus 3i. But plus or minus 3i lies outside. So, minus 3i appear here, plus 3i lies here. So, both lies outside. This and this will not come. So, that no need to think about these two. So, minus 1 comma minus 1 are the singular points which lies inside this circle. Okay. So, here given function is, given function I will write like this, because which singular point lies inside, that for the corresponding factor only you keep in denominator, remaining all you convert it into numerator. Already you know. Given function is z square minus 2z by, what it is, z plus 1 whole square into z square plus 9 or not. So, this you can write as z square minus 2z by z square plus 9 whole by z plus 1 whole square. Is it? So, this is in a form f of z by z minus a whole power n. F of z by z minus a whole power n. Okay. So, this is f of z by z minus a whole power n form. So, what is by integral formula? What is the output? Say. So, this is nothing but this is in a form f of z by z minus a whole power n. So, what is the formula? 2 pi I into, that is nothing but by integral formula. I will write it next line. This work I will do separately. So, here in place of n 2 is there, we have to find up to first derivative. What is f of z here? F of z is nothing but z square minus 2z by z square minus 2z by what it is? Z square plus 9. What is its first derivative? F dash of z is nothing but z square plus 9 whole square. Denominator square. Denominator into z square plus 9 into derivative of numerator 2z minus 2 minus numerator into z square minus 2z into derivative of denominator is 2z. Clear? So, f dash of 1 required. In place of a, what is there here? Minus 1 is there. So, that is f dash of minus 1. What is f dash of minus 1? Minus 1 whole square is 1 only, that is 10 into minus 1, that is minus 4, minus 2, minus 2. Okay, minus of 1 plus 2, 3 into 1 plus 2, 3 into 2z. 2 into minus 1 is minus 2. Is it? By 10 square is nothing but 100 or not? That is minus 40 minus 6. Minus 40 minus 6. Minus 46. Minus 40 plus 6, sorry. Minus 40 plus 6. (34 by 100). Minus 34 by 100. So, minus 17 by 50. That is f dash of 1. Now, therefore, by integral formula, therefore, by Cauchy integral formula, first I will write the formula, that is integral C f of z by z minus a whole power n dz 2 pi I into n minus 1th derivative of f at a by n minus 1 factor. So, therefore, integral C in place of f of z, what it is? Z square minus 2z by z square plus 9 by z plus 1 whole square dz is equal to 2 pi I into, say this. Here in place of n, 2 is there. So, n minus 1 is nothing but the first derivative or not? That is the first derivative of f at a is minus 1 by first derivative factor means 1 factor. That is 2 pi I into minus 17 by 50. Is it? That is nothing but minus 17 pi I by 25 is the answer. Option B correct. Understood?
Okay guys, now we see the questions from engineering mechanics. Now, in the pin jointed truss shown in the figure, which of the following members is or are zero force members, guys? It is a multiple select question. So more than one options are correct, guys. Now this is the given member. First we will check it, guys. Option A, DE. What is the DE guys here? DE means this is the member DE. So is it 0 or not? Definitely satisfy the second rule of zero force members guys. What is second rule guys? Adjoint D. Two are collinear. Third one is at an angle and there is no force acting at the joint. So this is a zero force member. Definitely this is a zero force member. Next BC. Satisfied or not? Yes. Take this BC. Again at this point, there are three members are meeting. Out of three, two are collinear, third one at an angle, then this force must be equal to 0 if there is no force acting at this location. This is also correct. Next JK. Now take it guys, JK. Now it satisfies the third rule guys. What is the third rule here? Same thing. At this location, only one reaction exists. As I told you in our classroom also guys, at this point, what happens here? Tell me sir here. Now, if you take it here, this one and this one, if there are two links are meeting, like this is the condition. If there are two links are meeting and there is an external force guys, so there is an external force or reaction which is acting along one link, then force in this one must be equal to 0. It is exactly similar to rule number 2 also. There are two forces are there, three members are meeting guys, or three forces are acting. Out of this two are collinear, third angle means the force in this member must be equal to 0. The same thing, the reaction is exactly aligned with this one JK, so this member having a zero force member. This is also having a zero force member. Next, CE. What is the CE guys here? Listen carefully. CE means this is the one. Yes. Now if you observe carefully, for finding this CE, sir, first at A, what happened guys? Two members are meeting and two are not collinear. As these two members are not collinear and there is no force acting at the joint, this force is a zero force member, this is also zero force member guys. If this is 0, this should be also 0 automatically. So CE should be also 0 guys. The right answer here is A, B, C, D. A, B, C, D. All four you have to give guys. If you ask me further zero force members guys, see. This is 0, this is 0, this is 0, this is 0, this is the zero force member guys, this is zero force member, this is the zero force member, this is the zero force member guys. You please think this is exactly what are the zero force members in this truss guys. I hope this is clear. Next, a 40-gram mass is released from a rest. This is the take care of the units guys, m equal to 40 grams not kgs is released from the rest on a smooth curved track. The given is a smooth curved track means what exactly? Friction equal to 0 guys. Terminating in a smooth horizontal track as shown in the figure. So from this curved track to it is terminating in a smooth horizontal track as shown in the figure. A spring of constant stiffness of the spring is given guys, is attached at one end of the horizontal track. Then find the maximum compression of the spring in centimeters. Take care of the units. In centimeters is asking, round off to nearest integer. What should be the answer guys here? Everyone listen carefully sir. First, as there is no friction, the friction is not there guys, I can definitely conserve the energy sir. Definitely I can assume this is the position 1. This is the position 2 guys. So energy at the position 1 must be equal to energy at the position 2 guys. Initial energy. What is the initial energy guys exactly? Initial position is exactly mass at this location. The spring is at this location guys. Then what is the energy it is having sir? Does it having? It is released not dropped. When it is released, velocity equal to 0 and I am taking this is the base guys. Then it is having only potential energy, gravity PE sir. What the gravity PE guys, anyone? mgh. This height equally given 4.9 guys. Now spring is constant, it doesn't have any mass, it is not compressed also, so that equal to 0 guys. Next, energy at drew. What is second position? It is dropped and push the spring guys. Push the spring and it compress the spring exactly when it is having a maximum compression. This is the spring guys, this is the maximum compression is happening x guys. This is the maximum compression distance is x guys, I can say. This is the second position. It is falling down and pushing the spring. There is a maximum compression is happening over there. How much distance, guys? The x distance is getting compressed, guys. Now, in the second position, what is the energy it is having? First, the mass. See, at the instant of maximum compression, what is the velocity of the mass, guys? 0. Yes or no, sir? It is coming and it's exactly maximum compressor means it is not further compression means what exactly? At that instant, velocity becomes 0. This is the point you have to remember, guys. At maximum compression, velocity equal to 0. At the same time, does the mass is having any potential energy? No. It is exactly lying on this one, guys. Yes or no, I can able to say, guys. Here two systems are there. Ke plus Pe of mass plus Ke plus Pe of spring, guys. Now, for the mass, Ke 0. P also 0 because exactly at the lying, this is my reference I have taken. This is the reference I have taken. This is also 0. Next, Ke of the spring is definitely 0. Why? Because it doesn't have any mass, guys. P, it is having a spring P. How much is the formula, sir? That equal to half mv square. Having little common sense, you can directly able to say, guys, that is what gravity PE must be equal to spring PE, sir. Not half mv square, so half kx square, guys. Half kx square is the potential energy stored in a spring, guys. Now tell me, sir, x equal to how much now? Square root of 2 mgh by k. Now take care of the units, sir. Take care of the units. See how I am taking care of the units. So 2 into m, how much is given, guys? 40 grams means 40 by 1000, guys. 40 by 1000 kg into g, how much, guys? 9.8, 1 or 9.8, you can keep it, guys, into h. What is the h, guys? 4.9 by, what is the k? Spring constant, how much is given, guys? K value equal to 400 Newton meter, guys. 400 Newton per meter. That's fine, guys. How much is coming, sir? Here, observe carefully. Anyone? That equal to, see, sir, 1 0, 1 0 getting cancelled, guys, here. So 1 will become 10, guys. So it will become 2 into 4.9 become 9.8 is equal to x equal to square root of 9.8 whole square by how much, sir? 1000 into 10. 10 power 4 I am going to get 10 power 4, guys. It is coming as 9.8 by 10 square. What are you going to get? Meter, guys. 9.8 by 10 square is the meter you are going to get. But I want the answer in terms of what exactly? Centimeters, guys. Centimeters. So what I can able to do it now? 9.8 by 10 square into 1 meter equal to how much, guys? Anyone? 100 centimeters, guys. So getting cancelled, the answer equal to 9.8 centimeters, guys. But I want in terms of nearest integer, that equal to how much? 10, guys. The right answer here is 10 centimeters. I hope this is clear, guys. Okay, guys. Now we see the questions from strength of material. First question for one more question, guys. An axial load of 2 kilonewtons is applied to the rectangular bar. There is a 2 kilonewtons load is acting, guys. Then maximum stress. Here there is a high confusion that is asking not maximum stress, is the maximum shear stress, guys. Developed in the bar is how much, guys? You know definitely, if you know basics of complex stresses, guys. Now when the axial load is acting, maximum shear stress will be developed on the inclined plane, guys. So on the 45-degree plane, what is this maximum shear stress value? Anyone remember, sir? This tau max must be is coming as anyone? Sigma by 2. Whatever the normal stress is coming, na, iska half you are going to get, guys. This sigma by 2 means, first of all, sigma means what exactly? Sigma means what exactly, guys? P by A. P by A. P equal to how much, sir? 2000 newtons, guys. 2 kilonewtons means 2000 newtons by area. This is the cross section area, guys. 10 into 5. How much? 50, sir. So it become how much, guys? 40 megapascal is a sigma, guys. The answer become 20 megapascal, sir. Sigma by 2 means 20 megapascal. Or another way is, guys, if you write a state of stress at any point, I'm going to have only sigma 1, guys. I'm going to have only sigma 1. Sigma 1 equal to how much, guys? P by A, that equal to 40 megapascal. Just now we have calculated. And there will be no stress in this direction. Sigma 2 equal to how much? 0. Sigma 3 also equal to 0, guys. Then, what is the tau max formula? Anyone remember? The maximum shear stress equal to, at any instant, at any point, equal to maximum of sigma 1 minus sigma 2 by 2, comma, sigma 1 by 2, comma, sigma 2 by 2. Yes, sigma 2 is 0, guys. So, maximum of sigma 2 is 0. Sigma 2 is 0, guys. Maximum how much is coming, sir? Anyone? Sigma 1 by 2, comma, sigma 1 by 2, comma, 0, guys. How much is coming, sir? This value, sir. Sigma 1 by 2 means how much? 40 by 2 is coming as 20. Again 40 by 2 coming as 20. The answer equal to 0. It should be equal to 20. Anyway, you can able to get the same answer, guys. I hope this is clear, guys. Now, coming to second question. If a material is having a shear modulus, it is having a shear modulus 60 gigapascals, guys, and bulk modulus 100 gigapascals. Then calculate Young's modulus in megapascal. This is the place you may get confused. You may give the wrong answer, guys. But everyone know he has given the, see, shear modulus is given, bulk modulus is given. Then what is the formula for the Young's modulus, guys? E equal to, straight away formula, guys, 9 kg by 3 kg, 3k plus g, guys. Now substitute 9 into k. K how much, guys? 100 into 60 by 3 into k how much, guys? 100 plus g how much? 60, guys. So it is coming, guys, if you can observe carefully, sir. Just if you can make it simplify this way, going to get 150 gigapascals you are going to get, guys. 150 gigapascals. So like we're going to get 360. This is the 360 here I am going to get. By on top, how much is coming, sir? 54. Yes. Thousand, guys, you can able to get, guys, 54,000. Yes, 150 gigapascals you are going to approximately, guys. 150 gigapascals you are going to get. But answer is coming as what I'm saying, megapascal, guys. Megapascal means how much? 150 into 10 cube megapascal, which means you have to give the answer in terms of what exactly? 150,000. So answer should be 150,000. Then only they will give the marks for you. I hope this is clear for you, guys. Yes, let me check. Yes, 150,000 is the answer, guys. Yes. Coming to this question, it's a 2 marks question. Really tricky question, guys. Consider the beam ABCD, ACDB given in the figure. Which of the following statements is or are correct? Means again it is a multiple select question, guys. Now there is sudden jump in bending moment of magnitude 4 kN at point D. This should be definitely wrong, sir. Why? Because at D what happens here? Observe carefully, sir. At D, what is the couple here? This is the 4. This is the 4. What is the distance between these two, guys? Anyone? 2 is the distance, guys. Here it is the 1, here it is the 1. 2 is the distance. Then what is the couple become, guys? On the beam will become clockwise or anti-clockwise? Clockwise couple. How much, sir? 4 into 2. 8 kilonewton meter, guys. Whenever there is a point couple of 8 kilonewton meter, there should be a jump. There should be a sudden jump in the bending moment diagram of what exactly? 8 kilonewton meter, but he's giving only 4, guys. So option A is wrong actually, sir. Getting answer everyone guys? Because the point couple is a 8 kN, jump of magnitude should be also how much? 8 kN guys. Next, there is no point of counterfluxes occurs on the beam. We'll check it guys. See, for this you should draw the free body diagram of this beam. See how I can able to draw the free body diagram. Very simple sir. First, see guys, whenever there is an internal hinge is given, you can keep one beam above the other sir. I am keeping, this is the one beam, this is the beam AC, this is the beam CB sir. Then you can get the answer easily guys. You can assume this beam also above it, this beam also below it, anything you will get the same answer guys. Okay, next, here the point couple already, how much is the point couple is acting guys, anyone? There is a point couple of, how much is acting guys? Point couple of 8 kilonewton meter is acting the point couple guys. Clear everyone? Now let me draw the free body diagram. If I draw the free body diagram of AC, how much is coming sir? This is the one. Here 6 is acting and the bottom will give you the reaction upward direction guys. This is the reaction upward direction. Guys, even if you can take it upward, you will take the reaction, you will definitely get the same answer guys. Next, again, this is the one. This will give you the downward reaction guys. As this is giving upward, this should give you the downward reaction guys. Same R because of action reaction. Then here, couple 8 kilonewtons is acting guys. Next, here how much again? RB will be coming guys. Now if you take only BC beam, BC segment of a beam, listen carefully sir. If you take only BC segment of a beam, definitely guys, as there is no point load, only point couple exists. How much is the point couple guys? 8 exists over here. Definitely this side support reaction R must be equal to how much guys? Sigma m by L. Standard case guys. Here support reaction equal to how much guys? Downward should be R must be equal to sigma m by L. I hope you remember sir. This concept we discussed multiple times in the class also guys. So R simply you can take moment about this point, you will directly get the reaction equal to sigma m by L only. Here m by L means 8. L is what exactly? Between the supports, how much is the length guys here? 2 by 2, 4 sir. Is equal to 2 itself. For getting answer everyone guys. So here reaction also equal to 2 itself. If I know the 2, how is the typical bending moment diagram for this one guys? This end it is 0. Here 2 into, till this distance how much guys? 2, 4. So 2 into 2, 4 will be coming here guys. And then, if you're looking from right hand side, listen carefully sir, looking from right hand side, what happens exactly? Clockwise become negative. If you look from left hand side, clockwise become positive na. Looking from right hand side, clockwise become negative means it is going to fall the water guys, moving down itself. You can take the section here, it will try to falls the water sir, negative side itself. How much? Downward 8. So minus 8 means already plus 4 is there. Plus 4 to minus 8 will become how much guys? Minus 4 will be coming guys. Again, it is exactly going to be 0. See, observe carefully sir, here bending moment here, it is changing from positive, it is a negative sir. This is a point of counterfluxation definitely exists at what location guys? At point D. POC definitely exists at point D guys. So, this option also wrong guys. Next, magnitude of shear force at the fixed end is 4 kilonewton. We'll verify guys. See, at the fixed end is asking sir, shear force at the fixed end, we'll verify guys. Now for this, I will take it only this part. Only this is the A, this is the C. So at A, what is the reaction guys here? This is the 6 is present. Reaction how much guys? R. R equal to how much we got? The previous step guys, R equal to 2 only. R equal to 2. This is become what exactly sir? Say R6 minus 2 become how much sir? 4. 4 is the net force acting downward direction guys. When the 4 is the net force acting downward direction, what is the shear force at this location guys? Anyone? Algebraic sum of the forces, I can say shear force at this location must be equal to what exactly sir? Support reaction. If you take a support reaction equal to R, support reaction R, then upward force equal downward force, R must be equal to how much, sir? 4 only. Yes, this is the correct, sir. There is a magnitude of shear force at fixed end is 4 kilonewtons, absolutely correct. Next, magnitude of bending moment at A is 20 kilonewton meter. Let me verify, guys. This is the 4, this is the 5, guys. 4 into 5, how much, sir? 20. So, bending moment here must be equal to how much, guys? 20 only. 4 into 5, 20 itself. The right answer here is, guys, C, comma D. If you're having little conceptual clarity, within 2 to 3 minutes, you can able to answer it, guys. Next, for the beam shown in below, the value of support reaction R at B is how much, guys? He's asking, what is the support reaction R at B? He's asking, sir. For this, what we can do? Very simple, guys. It is a statically determined or static indeterminate beam, guys. It is statically indeterminate, guys. How I can able to say? See, it's a proper cantilever kind of thing. See, 3 reactions will be present. 4. 1, 2, 3. 3 reactions at the fixed end, 1 reaction at the proper end, guys. 4 reactions are there, but we are having 3 equilibrium equations. So it is a statically indeterminate, guys. You can't able to get by using equilibrium equations. We need the compatibility equation. What is the compatibility equation, guys? This is the one. Deflection at B equal to 0. Net deflection at B equal to 0. That's why, as I'm finding at B, I don't need the remaining part. That's what I'm doing now. I'm transferring the force to B. See how I'm transferring, guys? Everyone listen carefully, sir. You transfer a force. How much? This is a force P with a couple. Couple how much, guys? Anyone? Couple M. Here P equal to how much, guys? Anyone? 20 kilonewtons. And M couple equal to how much, guys? 20 into 2, 40, guys. 40 kilonewton meter is the M is acting over there. Then ground reaction will be present, sir. Ground reaction R is acting upward direction. Ground reaction R is acting upward direction. But definitely, sir, what do you observe carefully? Deflection at B equal to 0 means what happens exactly? P and M will try to bend it downward direction, but R will try to bend it upward direction, sir. So net downward deflection must be equal to upward deflection, guys. Sir. So if you observe carefully, sir, this is identically splitting into, listen carefully, sir. Same beam, this is the P, this is the M. This will give you downward deflection, guys. How much is this downward deflection? Standard case. Standard case. How much is downward deflection, guys? And plus, what happens exactly, sir? R gives you upward deflection, sir. R gives you upward deflection. But net deflection equal to 0 means what exactly means, guys? Downward deflection must be equal to upward deflection. Downward must be equal to upward, guys. Now, downward deflection is due to what parameters, guys? Due to point load, due to M, guys. Due to point load, how much is the formula? PL cube by 3I. Due to M, how much, guys? Anyone? ML square by 2EI. Now, upward deflection equal how much, guys? R. Due to R, how much, guys? RL cube by 3EI. Now, EI is strike off everywhere, guys. L cube strike off everywhere. I'm going to get R equal to how much, guys? The 3 getting cancelled. P plus 3 by 2 times of M by L square by L cube means L I'm going to get. 3 by times of M by L we're going to get, guys. 3 by 2 times of M by L. This is what exactly I'm going to get, guys, for R. That equal to how much is coming, guys? Everyone listen carefully, sir. P value, everyone. So, P how much, guys? 20 plus 3 by 2 times of M, how much? 40 by length, how much, guys? 4 meters. Between only this much I require, guys. 4. So, it is coming as 20 plus 3 by 2 times of 10, guys. So, it is coming as 3 by 2 times of 10 means how much, guys? 20 plus 15. So, 35, guys. Kilonewtons. 35 is the answer, guys, here. The right answer here is 35, sir. 1 second, guys. Yeah, 35. 35 kilonewtons is the right answer here, guys. I hope this is clear for you. Now, coming to this question, find the correct match between the plane of state of stress and the Mohr circle, guys. He has given the state of stress and the corresponding Mohr circle itself. Now, if we take the first point, guys, everyone listen carefully. The first point, what happens here, sir? See, first here, no shear stress exists, guys, here. As there is no shear stress exists, guys, here. So here, sigma 1 equal to 0, sigma 2 equal to how much I am going to get, guys? Minus 20, sir. So sigma 1 0, sigma 2 minus 20. Which option is valid, guys, here? Yes. Sigma 1 starting is 0. Sigma 2 how much, guys? Minus 20. Definitely it is for the first one. Or you can simply keep it, guys. You can simply use the same stand thing, guys. Sigma x equal to how much? 0. Sigma y equal to how much, guys? Minus 20. Tau xy equal to how much? 0. Find out sigma 1 equal to c plus r. C means how much, guys? Anyone? Sigma 1 equal to c plus r, sigma 2 equal to c minus r. Sigma 1 formula c is how much, guys? Sigma x plus sigma y by 2. R is square root of sigma x minus sigma y by 2 whole square plus tau xy whole square, guys. Even if you do, you will get the same thing also. But simple thing, guys. Whenever shear stress is 0, the given state of stress itself is a principal stress itself. Now, second scenario, guys. Q. Again, there is no shear stress. If there is no shear stress, guys, again, sigma 1 equal to 20, sigma 2 also equal to 20, guys. This is possible when sigma 1 20, sigma 2 should be also 20. Here sigma 1 is 10, sigma 2 minus 10. No. Here sigma 1 is 20, sigma 2 is something is meeting the origin, guys. It should be meeting origin, guys, should be 0, guys. Next, yes, it is a minus 20 given. No, it should be plus 20, guys. Right option is 5, guys. So P1 Q5. So P1 Q5 is matching with only B. The right answer is option B itself. No need to think of anything, sir. Next, R again you can take it, guys. See, sigma 1 equal to minus 20. Listen carefully, sir. Sigma 1 equal to minus 20. Sigma 2 equal to 0, you can able to keep it, guys. Sigma 1 equal to minus 20, sigma 2 equal to 0 means you get the same Mohr circle for this one also, guys. You get the same Mohr circle for this one also. So R should be also 1 you are going to get. Next, yes, how much, guys? S is for the pure shear case, guys. Pure shear case means how much I am going to get, sir? Anyone? Pure shear case, guys. Please check it. See, in case of this one second, guys. So here it should be small correction, guys. It should be 10, sir, I think. This should be minus 20, guys. Sorry. This should be minus 20. This should be plus 20, guys. I'm sorry, guys. The small correction is there. It's a minus 20 plus 20 and all, guys. Now, here what happens here is sigma x equal to 0. Sigma y equal to 0, tau xy equal to 20, tau xy equal to 20, then center of the Mohr circle equal to sigma x plus sigma y by 2, 0. The radius equal to how much, guys? Square root of sigma x minus sigma y to whole square plus tau xy whole square, 20 square, guys. So R is coming as 20 itself. Then sigma 1 equal to C plus R. Sigma 1 equal to C plus R, guys. Sigma 2 equal to C minus R. So this is coming as 0 plus 20, 0 minus 20, sir. Plus 20 minus 20, guys. Plus 20 minus 20 is matching with the option 2 itself, guys. So the right answer here is option B. I hope this is clear, guys. Okay, guys, coming to the theory of machines pre-gate questions. First question, guys. One more question. The mobility of the mechanism shown in the figure is how much is asking, sir. First, you have to count the, what is the degree of freedom formula? F equal to, how much, guys? 3n minus 1 minus 2j minus 1h. Any higher pair is present, guys. Any higher is 1h, I can able to take it. But here no higher pair is there, this will be completely striked off, guys. Now, number of links. Fixed link is 1, link 2, say quaternary link, guys, 3. Quaternary links means 4 links can be connected here, guys. 1, 2, 3, this is the 4, this is the 5, this is the 6. So n equal to 6, guys. Yeah, n equal to 6. Number of joints. This is the J1. This is the J2. This is the J3. No. Why? Because, guys, why I should not count as joint? Because everything is a one link. There is a provision is there, but it is not connected to anything else, guys. I told you, when I can say it is a joint, guys, it should be connected to something else. That's why don't confuse, because the previous some questions are given like this, guys. You should be very careful. There is a provision is there, but not connected to anything else, guys. So I should not count as a joint over there. This is the J3. This is the, tell me, sir, J4. Here, J5 comma 6, guys. Why? Because 3 links are connected. 4, 5, 6. 3 links connected. I should count as a 2 joints, guys. Next, J7, guys, is the 1, 7, guys. Now substitute now. F equal to 3 into n minus 1 means 5 minus 2 into 7, guys. How much is coming, sir? 15 minus 14. The answer equal to how much? 1, guys. The right answer here is 1. The mobility of the mechanism is 1 itself, guys. I hope this is clear. Next, a system undergoes a free vibration with a viscous damping. Free vibration with a viscous damping means it's a damped vibrations, guys. The amplitude of vibration decreases from 5 mm to 0.5 mm after what exactly? 4 complete cycles, sir, which means that initial amplitude x0 is given as a 5. Then after completion of 4 cycles, if n equal to 4, x4 is given as how much, guys? Anyone? 0.5 mm. Then the damping ratio of the system is how much? What is the damping ratio? J equal to how much? This is what exactly he is asking, sir. This how we can able to find out, guys? Very simple, guys. See, for this standard formula based questions, sir, very frequently as you get in the GATE examination, guys, please go through it. How can I find out? First, you need to find out logarithm decrement formula. Delta equal to how much, guys? Whenever n is given, 1 by n into log natural of x0 by xn. This is the basic formula you should remember, guys. That equal to delta equal to 1 by 4 into log natural of 5 by 0.5, guys. So it is how much is coming, sir? Approximately, please calculate. Anyone? 0.57, sir. 0.57 is the logarithmic decrement delta got, guys. Then J he is asking, how can you find out the J, guys? You know this formula, sir. So delta equal to same thing. This delta equal to 2 pi J by square root of 1 minus J square. If you can rearrange the terms, you will directly get delta equal to, if you can rearrange the terms, guys, you are going to get J equal to delta by square root of 4 pi square plus delta. Yes, delta square, guys. Just rearrange the terms you're going to get. Because these are 2 standard formulas, guys. From this, just rearrange the terms, you're going to J equal delta by square root of 4 pi square by delta square. Now substitute, guys. 0.57 by square root of 4 into pi square plus again 0.57 square. How much is coming, sir? Please verify. It's coming as 0.09, guys. I hope. Please verify. You're going to get the same answer, guys. It's 0.09. I hope this is clear. Okay, guys, let's go. Let's see this question. A 4-bar mechanism ABCD is shown in the figure. ABCD. At this instant, the input crank AB rotates. The input crank AB rotates clockwise with an angular velocity of 4 radians per second, guys. He has given that omega 2 he has given, guys. Second link I am giving. This is a fixed link. This is a second link I am giving, guys. Omega 2 is given as 4. Then the instant center of links AB and CD lies at B. Just by seeing, I can't able to say, guys. AB, suppose AB and BC at B itself. But AB and CD, this you have to do it, guys. How I can able to do it? First, I'm giving, sir, this is the 1, link number 2, this is the link number 3, this is the link number 4. Now, just by seeing, I can able to say, this is the instantaneous center of I12. This is I tell me, sir, I23. Here, how much, guys? I34. This is how much, guys? I14, guys. The first link, this is the fourth link, sir. But it's asking what exactly? Instant center of link AB. AB means 2 and CD means 4, guys. Is asking I24 is how much is asking, sir? I24 equal to how much? Since the center of AB means second link, CD means fourth link, guys. How can you able to do it? Just by saying, you can't able to say, you have to use the merchant circle, like not merchant circle, Kennedy's theorem, guys. That is what exactly? Mark this one. The corners are with 1, 2, 3, 4. I want 2, 4, sir. I can get 2, 4 by joining 2, 3 and 3, 4. 2, 3 and 3, 4. I just joined 2, 3 and 3, 4. Next, tell me, sir. I will get also 2, 4 by joining what exactly? 1, 2 and 1, 4, guys. Where is 1, 2 and 1, 4, guys? Anyone? 1, 2. This is the 1, 4, sir. Yes. Where this line both are meeting at this location. The meeting point become what exactly? I24. This is the standard procedure, guys. Okay. Now what you observe from this? What is asking, sir? The instant center of link AB and CD means 2 and 4 lies at point B. Yes. This statement is correct, guys. Lies at point B. Absolutely correct, guys. Next. The angular velocity of coupler BC is 2.5 radians, 2.5 is asking, sir. So, omega 3 is asking, sir. Omega 3 is asking. Omega 3. For this again, I need the one more I center, guys. This is a 1, 3, I want I center. So, we'll also arrange this one, sir. 1, 3. How can I arrange 1, 3, guys? See, I'm connecting 1, 3. How can I connect 1, 3, guys? By joining 1, 3, by joining 1, 4 and 3, 4. By joining 1, 4 and 3, 4, yes. This is the one line, 1, 4 and 3, 4. Next one, tell me, sir. 1, 4, 3, 4. Next, 1, 2 and 2, 3, sir. Where is 1, 2, 1, 2 and 2, 3, guys? Again, I'm extending, sir. Where this line and this line is meeting at this location, guys. This is become what exactly? I13. Yes. This is because I13 and 14 is lying at the same location itself, guys. Now, I want to find out omega 3, guys. How can I find omega 3? Standard formulas, guys. First one is standard procedure, fixed link, input link, tell me, sir, input link and unknown link. Fixed link is what here? 1. Input link, what I have taken? 2. Unknown link, what exactly, guys? Unknown link is 3. Then I can say omega 2 into distance between 1, 2, 2, 2, 3 equal to omega 3 into 1, 3, 2, 2, 3 stand for, guys. Yes or no? Now, omega 2, how much, guys? Omega 2, how much he has given? 4 radians per second into 1, 2, 2, 2, 3. Where is the 1, 2, sir? This is the 1, 2. 1, 2 means his eye center 1, 2, guys. 1, 2, 2, 2, 3. This distance equal how much? 10. Must be equal to omega 3 he is asking. Omega 3 into 1, 3, 2, 2, 3, guys. Where is 1, 3, sir? Where is 1, 3, guys? 1, 3. Where is 2, 3? This distance, guys. How much this should be, guys? This is 20, this is 12. This should be how much, guys? 16. If you verify geometrically, guys, you're going to get this should be 16, guys. This should be 16. Yes or no, sir? How much is coming? Omega 3 equal to now? Omega 3 equal 4. 4, guys. 10 by 4 means how much, guys? 2.5. 10 by 4 means 2.5 itself, guys. 2.5 radians per second. So, answer is how much, guys? B, guys. Next, The incident center of link BC and fixed link lies at infinity. Link BC means what exactly, sir? Link 3 and fixed link is 1, which means 1 and 3, sir. 1 and 3 lies at infinity is saying, guys. See, where is 1 and 3 is lying, sir? At D location. It is not at infinity, guys. It is lying at D, not at infinity. So this statement is absolutely wrong. Next, the angular velocity of output rockery is 2.5 radians per second. Again, you should do, guys. Fixed link, input link, unknown link, what exactly? 4, guys. Same thing. Omega 2 into 12224 equal to omega 4 into 14224, guys. Now, omega 4 equal to, I can write down, omega 2 how much, guys? 4 into 12224, how much? Same 10 by 14, same 14224, how much, guys? Same 16, guys. It is coming as 2.5 only. Yes, it is also 2.5 itself. This comes B comma A comma B comma D. So such questions are rank deciding questions, guys. Very few people used to answer this question in a easiest manner. This is the way. If you are my student, you are able to answer such questions very, very easily, guys. I hope this is clear. Okay, guys, let's see this question. And I see by epicyclic gate train as shown in the figure, he has given that. This is the epicyclic gate train, guys. Number of teeth on gear A. This is the TA given as 20 and TB is given as 80. So B is the annular gear, guys. C is the idle gear which is connecting between A and B itself. The gear A rotates an angular speed of 4 pi radians per second in counterclockwise direction, guys. Assume gear A, it is rotating in a counterclockwise direction, guys. 4 pi radians. He has given that omega 2 or omega A is given as 4 pi, guys, radians per second. Then, what is the speed in terms of RPM, guys? Anyone? Omega equal to 2 pi n by 60, na? Which means that 60 into omega by 2 pi. How much is coming, sir? 120 RPM are going to get, guys. So NA equal to 120 RPM, guys. Next, the speed of the arm A is how much? The speed of the arm A is how much, guys? The speed of the arm A. What is the speed of the arm A? Simple, I'm assuming, guys. The speed of the arm equal, I'm assuming, guys, X RPM. Counterclockwise direction is what I am saying, guys. Next, the speed of the A, what is the stand formula, guys? Anyone? X plus Y. X plus Y, guys. What this X plus Y formula, guys, he has given this net value, because assume A also rotating, arm also rotating, sir. Net speed of A is given how much, guys? Anyone? 120 RPM itself. 120. Next, the speed of the B equal to how much, guys? The stand formula. So remember, sir, X plus or minus Y into, so speed of any gear equal to, guys, X plus or minus Y into pi of T of driver by pi of T of driven, guys. Driven. Now how much is coming, sir? X. Y plus or minus here, Y, guys, you please check once we discussed, guys. If A and B are rotating in the same direction, guys, so it is the plus, opposite direction, it is a negative. See, assume A is rotating in a counterclockwise direction. How C rotates, guys? Clockwise. B also clockwise, because the annular gear, guys, should be X minus Y. So T of driver, how much, guys? Anyone? TA by, because this has become like this is a TA into, listen carefully, sir, TA into A is driving C, C is driving B by T of driven, sir. C is driven by A, next B is driven by this one. CC getting cancelled, guys. How much is coming, sir? X minus Y into TA by TB, guys. This is the NB, guys. Tell me now I want to find out this value. This is given as 0, sir. Why this is given as 0, guys? Because B is stationary. My task is to find out this X equal to how much, guys? How can you find out? Please verify now. Observe carefully, guys. Now substitute now, everyone. So x minus y into TA by TB, 20 by 80 guys. How much is 20 by 80 means how much guys? 1 by 4 I am going to get equal to 0 guys. So I can going to get guys from this one y equal to 4x guys. I got y equal to 4x. Substitute in this formula sir. So x plus y means 4x, that equal to 120 sir. It becomes 5x equal to 120. So x equal to how much guys? 120 by 5. It become how much guys? Anyone? 24 RPM guys. Should be equal 24 guys. So x is the speed of the arm. I hope this is clear guys. Okay guys, check this question. A uniform rigid bar of mass 3 kg. This is having a uniform rigid bar guys. This is having a mass m equal to 3 kg and length L equal to 1 meter, is hinged at the point F and supported by a vertical spring of stiffness as given guys. It is supported by vertical spring of stiffness K equal to 100 Newton per meter. Assuming small angular oscillations and neglecting damping, the system is subject to a harmonic excitation guys. Then resonance of the system occurs at the frequency of here in hertz is asking sir. Here the resonance, when the resonance occurs guys, anyone? At the natural frequency, when exciting frequency equal to natural frequency, is intention is directly asking what is the natural frequency of a system equal to how much? Omega n equal to how much? The standard case guys. The simple system itself. Omega n, directly I am writing the formula. Omega n into square root. How many springs are there? One spring is there. Into distance how much guys? A square. K square by the inertia of all the systems guys. I naught. That's it sir. Now if you put 1 by 1 sir, so K means 100 Newton per meter. Distance how much guys, anyone? 1 square by I naught. What is the I naught formula sir, anyone? ml square by 3, because it is a uniform bar. ml square by 3, I naught equal to ml square by 3, which means that m is how much has given 3. L equal to 1 square by 3 itself. Answer equal how much guys? 1 itself. Answer equal to 10 radians per second is the omega n. But he's asking what exactly frequency sir. In terms of hertz he's asking sir. What is the relation f versus omega guys? Omega equal to 2 pi f. Yes or no? F equal to how much guys? Omega equal to how much sir? 10 by 2 pi. It is coming as, answer how much is coming sir? Please verify. 1.59. Hertz, 2 hertz guys. Frequency equal to 2. The answer equal to 2 itself guys. I hope this is clear because we are rounding off to nearest integer guys. I hope this is clear.
Dear students, welcome to Pre-GATE 2026. We'll be seeing the questions from the subject machine design. So here we have got the first question. If the helical spring is subjected to axial loading, then option A says that inner diameter particles are critical in compression. Option B says that outer diameter particles are critical in compression. Same way option C says that inner diameter particles are critical in tension. And option D says that outer diameter particles are critical in tension. So now let's try to understand what will be the stresses suffered by the element in the spring. So when it is subjected to compressive loading and the load will be transferred to the cross section, let's call this as F and this will be also F, and the load when it is transferred to the cross section, there will be a load as well as a couple will also be present, or basically that is going to produce the twisting. So this twisting will be equal to, let's say it is F times of E. Okay, this is for compression. Let me correct the direction. This is for compression. And next, in case of tension, so the direction of force F is reversed. So F will be considered upwards and the direction of twisting movement will be changed and this will be equal to Fe. So here we find that the particles which are present on the inner circumference are subjected to or will be suffering the most, and those particles are critical. Okay, so the particles which are at the inner diameter are critical in compression as well as they are critical in tension. Reason is that the direction of loading has not been given, whether it is a compressive load or tensile load. Based on that, option A and option C are the answers. Next question, if the notch sensitivity Q is equal to 1 by 2, then the relationship between theoretical stress concentration factor, that is KT, and fatigue stress concentration factor KF is given by dash. So here the relationship that is given by Kf is equal to 1 plus Q times of Kt minus 1. So Q is 0.5 over here. So we can write this as Kf is equal to, this is 0.5 into Kt is 0.5 Kt, and minus 0.5 plus 1 is plus 0.5. So we can rewrite this as 0.5 times of Kt plus 1. So this will be one of the equation, that is option B is the answer for this. And let's check the other one, because they are also asking you to frame an equation subject to Kt. Okay, so now this equation could be written as 2 times of Kf is equal to Kt plus 1, or Kt is equal to 2 times of Kf minus 1. So if I take 2 common over here, this will be Kf minus 0.5. That is Kt is equal to 2 times of Kf minus 0.5. So let's check the option. So option C is also the answer. That is 2 times of Kt is equal to 2 times of Kf minus 0.5. Okay. So for this question, option B and C are the answers. Next question, dear students, it is the bar which is subjected to axial load as shown in figure. Material properties of the bar are mentioned below. The yield strength in tension is 220 megapascal and corrected endurance strength is 120 megapascal. The load conditions that is related to first condition 1, that is 30 kilonewton, is been applied gradually at a constant rate. And the factor of safety N1 is the factor of safety in case of static loading. And to the existing static load, a cyclic variation of 10 kilonewtons is been applied so that the load becomes fluctuating on the bar, fluctuating load or reverse load that is being imposed. And N2 is the factor of safety in case of fluctuating load. The ratio of N1 to N2 is dash. So first is that we can write the loading condition or loading equation for the static case. So applied load should be less than the safe stress, that is sigma Yt by factor of safety, that is N1, into area. Area is pi by 4 times of d square. This would be area. Okay. So now here we can write, or subject to N1 if we make it, then this is equal to, that is N1 should be equal to P into, that is sigma Yt by into area, that is pi by 4 times of d square whole divided by P. Here P is the static load. This would be equation 1. Now simultaneously, along with the static load, there is a cyclic load of 10 kilonewtons is being imposed on the bar. So under that case, the mean load will be equal to, that is P static load plus 10 plus P static load minus 10 divided by 2, which is in short equal to the static load itself, PS, and that is 30 kilonewton. And amplitude load, even if you try to take the differences between these two, PS and PS will get cancelled and this will be 10 kilonewtons, that would be the amplitude load. So now for that case, the fluctuating load, if we express, that is mean load divided by area divided by yield strength in tension, that is SYT, yield strength in tension, plus amplitude load divided by area whole divided by endurance strength or corrected endurance strength equal to 1 by factor of safety, that is N2. Now if we simplify for N2, so by taking the LCM and then if we rewrite it, this would be product of SYT into endurance strength into area divided by, this is mean load into SE plus amplitude load into SYT it would be. This is the simplification, or when we write it subject to the factor of safety, that is N2. Now we are supposed to take the ratio of these two entities. This will be, let's say, equation number 2. So now here if we write N1 by N2, that is equal to SYT, that is yield strength, into area divided by load, static load, which is 30, whole divided by SYT into endurance strength into area whole divided by mean load into endurance strength plus amplitude load into yield strength. So now from here, here I have written it as sigma YT. Instead it should be written as SYT because sigma indicates the stress and S indicates the strength. Okay, so from here SYT and SYT will be cancelled, area and area will be cancelled out, and next is this will be mean load into endurance strength plus PA, that is amplitude load, into yield strength whole divided by, this is P into yield strength. So mean load we have is 30 kilonewtons, this is 30, into endurance strength is 120, okay, and amplitude load here it would be 10 kilonewtons straight away, 10 into, next is yield strength in tension, it is 220 whole divided by the static load even that is also 30, and yield strength is equal to 120. So this will be slight A values which is greater than 1 only. Okay, because 30 into 120 and 30 into 120 is both are there in the denominator. Along with that 2200 is additionally being added. So upon solving this, you will get the answer as 1.61 approximately. Let me check it. 1.61 would be the answer.
Let us take up question from the subject of fluid mechanics. The first question is saying, for a steady laminar incompressible boundary layer flow or a sharp, this is supposed to be sharp edged, this is supposed to be sharp edged flat plate at zero incidence. There are 4 options given. The first option is saying the edge of boundary layer is a streamline. This is wrong. The edge of boundary layer is a path line. This is also wrong over here. It is neither streamline nor path line. The next thing is the skin friction coefficient decreases as a distance from leading edge increases. This is true actually. If you recall, the value of CF is equal to 0.664 by root over of REX in the case of laminar boundary layer. So this implies the value of CF over here has to be proportional to 1 by root over of X. So therefore option C over here is correct. Okay, next thing, the skin friction coefficient remains constant. If C is correct, D has to be wrong then. So answer is option C over here. Moving further,
This is a numerical answer type question. The question is saying for a fully developed flow of an oil in a pipe having diameter of 10 centimeter, velocity 0.1 meter per second, kinematic viscosity 10 power minus 5 meters square per second, the value of Darcy friction factor is equal to how much? Now what I'm going to do is I'm going to calculate the value of Reynolds number first of all. Reynolds number is equal to Vd by nu, which is equal to velocity is given as 0.1, diameter is again 0.1, and viscosity kinematic is equal to 10 power minus 5. This yields a Reynolds number of 10 power 3 or 1000. Now since this is falling within laminar range, I can use the formula friction factor equal to 64 by Re in the case of laminar flow through pipes. So this value comes out to be 0.064. The answer over here is 0.064. Take if I put in 1000 over here. Very simple question. Let us move further now. The next question over here. This is a very good question. Okay, it has appeared already in XE GATE paper many years back. The question is saying for a given location in a flow, the rate of change of density following a fluid particle is given by, the total rate of change is given by capital D rho by capital dt is equal to dou rho by dou t plus u dou rho by dou x plus v dou rho by dou y plus w dou rho by dou z. Its value is equal to 2.4 kg per meter cube second. If the density at this particular point is 1.2 kg per meter cube, then the divergence of velocity field at this point is equal to how much? Now, how do we answer this question? Very basic question on continuity equation. Now, we know by continuity equation that dou rho by dou t plus dou by dou x of rho u plus dou by dou of rho v by dou y plus dou of rho w by dou z has to be equal to how much? 0. This is the value. Now if I open each of these up, I am going to have UV rule applicable, which implies rho into dou u by dou x plus u into dou rho by dou x. Same thing if I do over here, rho into dou v by dou y plus v into dou rho by dou y. And lastly, for this thing, if you apply UV rule, you are having dou rho into dou w by dou z plus w into dou rho by dou z. And as it is the first term, that is a local term is also coming, that is dou rho by dou t. This entire value over here has to be equal to 0. I hope it is clear till here. Now this part of the question is, this part of this equation is already given in the question. If you see this part over here is equal to how much? It is equal to 2.4. So this part is equal to 2.4. If it goes over there, it becomes minus 2.4. And I can take rho common. So if I take rho common, multiply to dou u by dou x, dou v by dou y, dou w by dou z gives me divergence of velocity field is equal to minus 2.4. Minus 2.4. That means divergence of velocity field is minus 2.4 by rho. Rho is 1.2. So from here I get divergence of velocity field is equal to minus 2.4 divided by 1.2, which should give me minus 2 per second, minus 2 per second. So the answer over here is minus 2 per second, minus 2 second inverse. That gives me answer as option C. I hope it is clear till here to all of you. Moving further to the next question. This is again from kinematics. This is from the concept of acceleration. The question is saying the velocity field within a laminar boundary layer is given by the expression velocity vector is equal to b u infinity y by x power 3 by 2. This is 3 by 2 over here, I cap, plus b u infinity y square upon 4 x power 5 by 2 j cap. The value of b is given, u infinity is given. The question is asking the x component of acceleration is equal to how much? Now x component of acceleration, I see my x component of velocity is a function of both u and v. So therefore the x component of acceleration over here is equal to u into dou u by dou x plus V into dou U by dou Y. This is the value. Of course, two more terms are there, but those terms will be equal to 0 over here. And if I do this thing, what am I going to get now? U is equal to Bu infinity Y, Bu infinity Y by x power 3 by 2 into. Now dou U by dou X, you see it is having x power minus 3 by 2 basically. So its value will come out to be equal to minus 3 by 2 into Bu infinity Y by x power 5 by 2. This is the first term. The second term over here, U is equal to Bu infinity Y square by 4x power 5 by 2, 4x square, 4 this value 4x power 5 by 2, this is V multiply 2. If I differentiate U with respect to Y, I am going to get over here into Bu infinity. If I differentiate with respect to Y, then one second, Y is gone, divide by x power 3 by 2. This is what I am having. Okay. Now, if I calculate this thing, what am I going to have then? This is equal to, if you see this term over here, B square U infinity square Y square minus 3 by 2 x power 8, x power 4. So minus 3 by 2 B square U infinity square Y square by x power 4 plus this value comes out to be equal to B square U infinity square Y square by 4x power 4. B square U infinity square Y square by 4x power 4. This is the value. This is 3 by 2, which is 1.5, that is 1 by 4, that is equal to 0.25. 1.5 minus 0.25 is equal to 1.25. So this is minus 1.25 B square U infinity square Y square x power minus 4. This is the answer actually. Now if you put in these values of B, U infinity, X and Y according to what are given over here in SI units, you will get the value of this thing as minus 5 over here. You will get this value exactly as minus 5. I hope this is clear. This is a basic question. This is a basic question from the concept of kinematics. Next question over here is the last question in this topic. The question is saying gate ABC in the figure is 1 meter square and is hinged at point B. It will open automatically when the water level H becomes high enough. Determine the lowest height in meter for which the gate will open. Neglect atmospheric pressure. He has given 4 options over here: 0.33, 0.66, 1.33, 1.66, all of them are in meter. Now for this gate to open up over here, you can see one very interesting thing. I am having a stop. This thing over here, it is called a stop. Okay, I am having a stop over here. That means if I look at the free body diagram of this gate, there is a hinge present over here. I am going to have a hydrostatic force over here. The stop is going to provide a reaction in positive x-axis. Now as long as this condition is prevailing, I am fine. But the moment this hydrostatic force goes above a hinge, then it is going to create an anti-clockwise movement. This reaction also will create anti-clockwise movement. The gate has to open up. So the critical condition is when the hydrostatic force is coinciding with the hinge. Now for hydrostatic force to coincide with the hinge, mind you, you see over here, this gate is 1 meter tall and 60 centimeter is present from A to B, from top to hinge. That means I am having an eccentricity minimum allowed over here is equal to 0.1 meter. Eccentricity minimum allowed is equal to how much? 0.1 meter. I have to use this logic now. If I use this logic, I will get the answer. Okay. If my eccentricity goes below 0.1 meter, that means my hydrostatic force is going above point B, then the gate will automatically open. Now recall what is the formula for eccentricity? It is I sine theta upon area times h bar, upon area times h bar. This is equal to how much? This is equal to 0.1 meter. Now if you see, this is a vertical gate, therefore sine theta over here has to be equal to 1. So I upon area h bar is equal to 0.1. Let us solve this thing. I am having an equation over here, I upon area h bar is equal to 0.1. Now what is the value of I? I is equal to BD cube by 12. So in this case, because it's a square plate, B and D both of them are 1 meter. So 1 by 12. Area is equal to 1. H bar over here is equal to H plus 0.5. So H plus 0.5 has to be equal to 0.1. This means 1 by 12 H plus 6 has to be 1 by 10. This implies 10 is equal to 12H plus 6. This implies 12H is equal to 4. H is equal to 4 by 12, which is equal to 1 by 3, or you can say 0.33 meter. The value of H I am getting is 0.33 meter. We have an option over here supporting that is option A. The correct answer over here is option A. I hope this is clear. With this, we complete the questions in pre-gate from fluid mechanics.
Good morning, my dear students. I am Dr. G.S. Sharma, faculty at ACE Engineering College, teaching heat transfer from Mechanical Engineering Department. The pre-gate question solutions, if you take it, the first question, NTU of a regenerator used in gas turbine regenerative plant is 4. Then its effectiveness is. Whenever you are going for regenerators used in gas turbine plants, so suppose you take a gas turbine plant, you keep a regenerator here, then you have a combustion chamber, then you have a turbine. And you should be knowing that the exhaust temperature of gases leaving the gas turbine, this is your compressor and turbine, is minimum at around 540 degrees centigrade or in and around say around 800 Kelvin. So these gases are sent through a regenerator which will preheat the air coming into your gas turbine. So you have air here and you have air plus fuel mixture. You should be knowing that the gas turbine is low specific fuel consumption engine where the air fuel ratios are as lean as 100:1. So this can be assumed to be a balanced flow heat exchanger where mass flow rate into its specific heat, hot fluid, is equal to mass flow rate into specific heat of cold fluids. So it's a balanced flow and counter flow heat exchangers because the current are in opposite directions. So for this particular case, effectiveness of a counter flow heat exchanger where it is a balanced flow heat exchanger is NTU by 1 plus NTU. This is corresponding to your CR ratio C minimum divided by C maximum value is equal to 1. So this is the relation. We have given NTU is equal to 4 number of transfer units. So this becomes 4 divided by 4 plus 1, which is 4 by 5. Answer is 0.8. Very important question. Then let's go to the next question. The thermocouple is designed to measure temperature of a fluid in a tube, which operates at a time equal to 2 times its thermal time constant. Then the temperature measured by the thermocouple is, you should be knowing that the response of temperature measurement T minus T infinity by T naught minus T infinity is equal to e to the power of minus tau by tau star. And this T is temperature recorded by thermocouple. And T infinity is temperature of the fluid. So, it is given that for a time tau equal to 2 times tau star, that is T minus T infinity by T naught minus T infinity is equal to e power minus 2, 0.135. Error is 0.135% or 13.5% is error. Error is 13.5%, whereas T is equal to 0.865 of T infinity plus 0.135 of T naught. If I substitute this particular value in this and write in terms of T. So, the temperature measured by the thermocouple is 86.5% of temperature of the fluid. Answer is B. Clear? The question he is asking you response rather than the error. Then, two infinitely long and parallel plates are maintained at a temperature of 27 degrees centigrade and 327 degrees centigrade, which has emissivity of 0.4 and 0.4 respectively. A thermal shield of emissivity 0.05 on both sides is placed between them. Equilibrium temperature of the shield. This is very, very important question. So, suppose I am taking two particular shields. I am taking two particular plates. This is plate 1 and this is plate 2. Plate 1 is maintained at a temperature of 327 degrees centigrade plus 273 comes out to be 600 Kelvin. Whereas T2 is at 27 degrees centigrade plus 273 comes out to 300 Kelvin. Now, this has an emissivity of 0.4, this also has an emissivity of 0.4. A shield is placed between them exactly at the middle where the, where this value of emissivity, is 0.05 on this side and it is 0.05. So, the surface resistance, if you write it in terms of a circuit, you have surface resistance, space resistance and surface resistance. This is EB1, J1, JS1 and this is EBS. Again, on the other side, you have surface resistance, space resistance, again surface resistance. This is EB2, J2, JS2. And if you are writing the resistors, this resistance is, see, this 1 minus 0.4 by 0.4. This is 1. This is 1 minus 0.05 by 0.05. Again, this is 1 minus 0.05 by 0.05. This is 1. 1 minus 0.4 by 0.4. That means resistors towards right space in this region and resistance towards left space in this region are same. Then I will write EB1 minus ES, EB1 minus ES divided by resistance in left is equal to ES minus EB2 towards resistance on right. As resistances are same, this resistance and this resistance are same, we will clearly write the relation as EB1 minus ES is equal to ES minus EB2, emissive power. So, this comes out to be ES is equal to EB1 plus EB2 divided by 2. Sigma Ts power 4 is sigma T1 power 4 plus sigma T2 power 4 divided by 2. So, I will write here, I'll write it here, Ts power 4 is equal to T1 power 4 plus T2 power 4 divided by 2, or Ts is equal to 4th root of 300 power 4 or 600. T1 is 600 power 4 plus 300 power 4 divided by 2. Very, very important thing. If he gives emissivity is same and emissivities of the shield on both sides are same, you need not do all the calculations. As resistances are same, directly use this EB1 minus ES is equal to ES minus EB2, or emissive power of your shield is equal to sum of average of the emissive powers of the first shield, of the first surface and second surface, and then calculate. Answer is 512.24 Kelvin. So, if you want, I will write it again. EB1, I think I am done with it. There's no slide on there. So, this is what I have it. Let me explain you again. This particular question, if you observe it, properly designed, wherein he is nowhere telling that heat exchanger is a counterflow and balanced. Wherever you are going with regenerators used in gas turbines, they are counterflow in nature and balanced flow. Counterflow, and your mass flow rate m dot h ch is equal to m dot c cc. In such cases, effectiveness is given by NTU by 1 plus NTU. Then, in the second one, we are looking at temperature measurement. Generally, in textbooks, they talk about error. When time is equal to, or tau by tau star equal to 2, when tau by tau star equal to 2, error is 13.5%. And how much it has measured is 86.5% of the fluid temperature. Then the third one, it is slightly an advanced question in radiation specific to gray bodies, specific to thermal shields, and we are not asking you any other parameter, but I am asking you what is the equilibrium temperature that is attained by the shield, which is equal to 512.24 Kelvin. So all the best. Those who have cracked this solution, well and good. If not, try to take the bird's eye perspective out of the box and read over and above what we are giving it. Thank you. All the best.
Dear students, look at the question asked for 1 mark. It is like this. Which one of the following is the correct statement? Two adiabatic curves will, option A, intersect at absolute zero temperature, B, never intersect, option C, become orthogonal at absolute zero temperature, D, become parallel at absolute zero temperature. Dear friends, remember, two adiabatic curves never be intersecting. Option B is absolutely correct. Two adiabatic curves never be intersecting. Similarly, two isothermal curves also never be intersecting. But isothermal curve and adiabatic curves can be intersecting because of the slope difference. Okay, it is like this. If I take the isothermal rule, isothermal means constant temperature process. At constant temperature, according to Boyle's law, product of pressure and volume remains constant. Then if you want to know the slope of the isothermal curve in the PV coordinate system, you differentiate it on both sides. Then it is PdV plus VdP is equal to 0. Differentiation of constant is 0. Can also be written as PdV is equal to minus VdP or dP by dV at constant temperature is equal to minus P by V. Dear friends, remember, the quantity dP by dV at constant temperature is the slope of isothermal curve in the PV coordinate system. Okay, a negative sign in the slope indicates as the pressure increases, volume decreases, because the isothermal process may be supporting for either compression by adding the cold source or expansion by adding the hot source. In the compression process, as the pressure increases, volume decreases. That's why, since the pressure and volume are reciprocal at constant temperature, the slope of the isothermal curve in the PV diagram is negative. That means, as the pressure increases, volume decreases. Similarly, if you want to know the slope of the reversible adiabatic curve in the PV coordinate system, the reversible adiabatic rule is PV power gamma equal to constant, where gamma is the adiabatic index. Now, if you want to know the slope of the reversible adiabatic curve in the PV coordinate system, you differentiate it. P gamma V power gamma minus 1 dV plus V power gamma dP is equal to 0. Differentiation of constant 0. Okay, simple mathematics, school level mathematics. Can also be written as gamma P V power gamma by V into dV is equal to minus V power gamma dP. Here V power gamma, this part will be cancelled. Then gamma P by V into dV is equal to minus dP, can also be written as dP by dV in the reversible adiabatic process is equal to minus gamma P by V. The quantity dP by dV is the slope of reversible adiabatic curve in the PV coordinate system. The negative sign indicates as the pressure increases, volume decreases, because adiabatic process may also be supporting for either compression or expansion with perfect insulation. Okay, that means during the compression process, while the pressure is increasing, volume decreases and vice versa. That's why the slope will be negative. Okay, then let us decide the relation between the slopes of isothermal curve and adiabatic curve. Here we got dP by dV at constant temperature is minus P by V, whereas the dP by dV in the reversible adiabatic process is minus gamma into P by V, can also be written as gamma into minus P by V. As you all know, minus P by V is the slope of isothermal curve. Therefore, the dP by dV in the reverse adiabatic process is equal to gamma times the dP by dV in the isothermal process. As you all know, gamma always more than 1. Since gamma is more than 1, I can say that the dP by dV in the reverse adiabatic process is more than dP by dV in the constant temperature process. That means slope of the reverse adiabatic curve in the PV diagram is more than that of isothermal curve. That means while you are marking the PV diagram for adiabatic process and isothermal process, the adiabatic process curve must be drawn with more slope than isothermal curve. Then if you ask me to mark the isothermal curves or adiabatic curves, two adiabatic curves, look at the pressure versus volume diagram. Let this is the one adiabatic curve, this is another adiabatic curve. Two adiabatic curves are always parallel to each other. Let us mark the slope also. Let this is the direction. Each curve slope is minus gamma P by V. These two curves are following the rule PV power gamma equal to constant. From that you can conclude that two adiabatic curves are always parallel to each other. It means they cannot be intersecting. But adiabatic curve and isothermal curve can intersect because of the slope difference. Pressure versus volume diagram. Let me mark the isothermal curve. The isothermal curve must be drawn with less slope equal to minus P by V, whereas adiabatic curve must be drawn with more slope 1 to 2 dash. This curve is following the rule PV equal to constant, whereas this curve is following the rule PV power gamma equal to constant. From this I can say that adiabatic curve and isothermal curve can be intersecting in the PV diagram, but two adiabatic curves never be intersecting. Therefore, we opted the option B. I hope all of you clearly understood. I try to explain the each and every point at your easily understanding level. Understood or not? Yes. Dear students, look at the another one more question asking like this. Two isobaric curves for a Brayton cycle in TS diagram. You know, for Brayton cycle, heat supplied and heat rejection takes place at constant pressure. That's why Brayton cycle is also called constant pressure cycle. Like how for the Otto cycle, heat addition and heat rejection takes place at constant volume. Anyhow, two isobaric curves for the Brayton cycle in TS diagram parallel to each other for same entropy change, not correct. Converging for same entropy change, also absolutely wrong. Diverging for same entropy change, absolutely correct. Diverging with different entropy change remains same. Option C is absolutely correct. It is asking for Brayton cycle. As you know, Brayton cycle is the theoretical cycle for the practical constant pressure gas turbine power plant. Once again, the Brayton cycle is the theoretical cycle for constant pressure gas turbine power plant. Okay, if you look at the constant pressure gas turbine power plant, mainly consists of two work interacting devices like compressor and expander. Two work interacting devices like compressor and expander, and two heat interacting devices like combustion chamber. This is the combustion chamber and this is the cold chamber. You can also say cooler. This is the cooler. The two heat exchangers are constructed to work at constant pressure, and two work interacting devices like compressor and turbine, gas turbine, are constructed to work at constant entropy. Entropy remains constant. Okay, that means that is working by reverse adiabatically with perfect insulation. Now let us mark the insulation. The turbine also perfectly insulated for avoiding the heat transfer. Now for this compressor, the working material is entering at state 1 with a pressure P1, temperature T1. Assume that temperature is 300 Kelvin. Then the gas is compressing with the rotary compressor like centrifugal compressor or axial flow compressor. After compression, the gas is maintaining high pressure and high temperature. This is the state 2 where the pressure is P2. Temperature after compression may be, let it be 500 Kelvin. During the compression process, while the pressure of the gas increases, the nature of the gas is that along with the pressure, temperature also increases. Assume the temperature is increasing from 300 Kelvin to 500 Kelvin in the compression process. And this is the place where the fuel is burning. We are supplying the fuel. That fuel is burning inside the combustion chamber. Because of the fuel burning at constant pressure, the temperature of the large amount of heat energy generated, that generated heat, right? The generated heat is causing for increasing the temperature. The temperature can be increased to peak value. This is the state 3 where the pressure is P2 only, but temperature T3 is the T maximum. That is the peak temperature. That peak temperature depending on the metallurgical limitation of the material what you are selecting for gas turbine. Assume this T3 equal to 1500 Kelvin. You can allow the gas temperature up to 1500 Kelvin for gas turbine power plant. That is the peak temperature. With this pressure P2 and maximum temperature, the gas is made to expand in the turbine isentropically. Because of the expansion, the gas pressure is decreasing along with the pressure, temperature also decreases. Let us say the gas pressure is dropping from P2 to P1 and the temperature also dropping from T3 to T4. Let the T4 is 800 Kelvin. During the expansion process, pressure decreases along with the pressure, temperature decreases. That means the gas is losing the thermal energy. That loss of thermal energy of the gas is converted to mechanical energy. Again, that mechanical energy may be converted to electrical energy by the time the turbine shaft cuts the magnetic field in the alternator. So with this low pressure and temperature, the gas is returned to compressor. Gas is returned to compressor through the cooler. In the cooler, the gas will be cooled. Right? So without this cooler, you cannot construct the gas turbine power plant, because gas turbine power plant also coming under a kind of heat engine. According to Kelvin Planck statement, at least 2 thermal reservoirs are required for constructing the any heat engine. One for supplying the heat, other for rejecting the or receiving the heat. Anyhow, in this cooler at constant pressure, the temperature of the gas is dropping from 800 Kelvin to 300 Kelvin. Okay, so this heat rejection in the cooler is taking place at constant pressure, and heat supplied in the combustion chamber is taking place at constant pressure. But look at the temperature gain during the heat addition. Temperature is gaining during the heat addition from 500 Kelvin to 1500 Kelvin. That means the gain in temperature of the gas is 1000 Kelvin. But how much temperature is dropping during the heat rejection from 800 Kelvin to 300 Kelvin? That is 800 minus 300, 500 Kelvin only. That means the temperature rise during the heat supplied. The temperature rise during the heat supplied is equal to, right, is equal to 1500 minus 500 is equal to 1000 Kelvin. Whereas the temperature drop during the heat rejection is from 800 Kelvin to 300 Kelvin. According to our assumption, it is around 500 Kelvin. Now compare the temperature gain during the heat supplied and temperature drop during the heat rejection. The temperature gain during the heat supplied is more than temperature drop during the heat rejection. Okay. So having this information, let us mark the TS diagram, temperature versus entropy diagram for gas turbine power plant. The temperature versus entropy. Since it is having two constant pressure lines, let me mark the two constant pressure lines. This is the pressure before compression P1, this is the pressure after compression P2. The two constant pressure lines must be diverging from left to right. The reason I will tell you. Look at the compression process. Very first process is compression process. This is the 1-2 isentropic compression, followed by 2-3 constant pressure heat addition process, 3-4 isentropic expansion process, and 4-1 constant pressure heat rejection process. So whatever the entropy which is increasing during the heat supplied must be equal to entropy dropping during the heat rejection. Then what is the slope of the constant pressure curve? The slope dt by ds at constant pressure equal to T by Cp. Mathematical formula remaining same. This is the slope of the constant pressure curve in the TS diagram, T by Cp. This entropy change remains same during the heat supplied. Entropy change is remaining same during the heat supplied and heat rejection. But this dt, the change in temperature, the increase in temperature during the heat addition is very high, that is 1000 Kelvin according to our assumption, compared to temperature drop during the heat rejection. That's why for the same entropy change, the two constant pressure lines are diverging from left to right in the TS coordinate system for the Brayton cycle. Understood? The two constant pressure lines must be diverging for the Brayton cycle from left to right, because the temperature rise during the heat addition is more compared to temperature drop during the heat rejection, though the entropy change remains same during the heat addition and heat rejection. Therefore I opted the diverging, the two constant pressure lines are diverging for the same entropy. Option C is absolutely correct. I hope all of you clearly understood. Understood or not? Yes. Dear students, now let us take the 2 marks questions. Look at the first 2 marks question asked for Carnot heat engines like this. 3 Carnot engines E1, E2 and E3 operate in series between 2 heat reservoirs which are at temperatures of 1000 Kelvin and 300 Kelvin. Between the 1000 Kelvin reservoir and 300 Kelvin reservoir, 3 Carnot heat engines are arranged in series. Okay. Calculate the intermediate temperatures if the amount of work produced by 3 engines is in the proportions of 5:4:3. Different options are available. Now first let me briefly discuss the Carnot heat engine. Carnot heat engine is operating between the 2 reservoirs. Let this is the high temperature reservoir, I can say hot source, and this is the low temperature reservoir, I can say cold source. This is the cold source, and this is the Carnot heat engine. Carnot heat engine. That Carnot heat engine is receiving the heat energy from the hot source. The amount of heat received by the Carnot heat engine from the hot source is Q1, while the hot source temperature is T1. As you know, a part of the heat energy is converted to work energy. The remaining is dumped to the cold source. The amount of heat dumping equal to Q2 to the cold source while it is maintaining constant temperature T2. That is the Carnot heat engine. For this Carnot heat engine, let us write the energy balance equation. Total energy entering to the system must be equal to energies leaving from the system. Energy entering is Q1, energies leaving are work output and heat rejection, W plus Q2. The work output equal to Q1 minus Q2. Q1 minus Q2. Okay. As you know, for Carnot heat engine, the Q1 by T1 is equal to Q2 by T2 because Carnot heat engine is the reversible heat engine. Q1 by T1 equal to Q2 by T2. From this I can write that Q is proportional to temperature. Q is proportional to temperature. For any reversible heat engine operating between the two temperature limits, heat is proportional to temperature. Now look at the work output. Since work output equal to Q1 minus Q2, therefore I can say that work output is proportional to T1 minus T2 because Q1 is proportional to T1 and Q2 is proportional to T2. That is the meaning of Q is proportional to T. Okay. Having this information, here we got the conclusions. Work output equal to Q1 minus Q2 and the heat is proportional temperature. Therefore, work output is also proportional to the temperature limits of that particular Carnot heat engine. Okay. Now, in our problem, 3 heat engines, Carnot heat engines are connected in series between the 2 reservoirs. One is 1000 Kelvin, other one is 300 Kelvin. For that, first let me mark the source 1. The source 1 is maintaining temperature T1 is equal to 1000 Kelvin. And this is the cold source. In between these source, this is maintaining 300 temperature. Let this is the temperature T equal to 300 Kelvin. In between these 2 reservoirs, there is another source. 3 Carnot heat engines are placed. Let me place the 3 Carnot heat engines. This is the Carnot heat engine 1. This is the Carnot heat engine 2. And this is the Carnot heat engine 3. But each Carnot heat engine is working between the 2 temperature limits. That's why between the for the Carnot engine 1, there must be 2 sources. This is the intermediate source. Let this the source 2 is maintaining T2 temperature. Then source 1 is giving Q1 amount of heat energy for the first Carnot heat engine. The first Carnot heat engine is converting only a part of the heat energy to work energy. Remaining is dumped to the source 2, while the source 2 is maintaining T2 temperature. Whatever the heat rejected by the first Carnot heat engine to source 2 is received by the second Carnot heat engine. A part of this Q2 is converted to work energy. The remaining is dumped to another source. Let that is source 3. The heat rejected by the Carnot heat engine 2 is Q3. That means a part of the Q2 converted work energy remaining is dumped to cold source is maintaining the temperature T3. Whatever the heat dumped by the Carnot heat engine 2 is received by the Carnot heat engine 3. The amount of heat received by the Carnot heat engine 3 is Q3. 1 minute. Space 1 minute. I will mark the third Carnot heat engine downside. Let this is the Carnot heat engine 3. That heat engine is receiving the heat energy from the source 3. The amount of heat receiving is Q3. A part of Q3 is converted to W3. The remaining is dumped to the source. Let this is the source 4. The amount of heat rejection is Q4. Well, it is maintaining T4 temperature. That is the arrangement for the Carnot, 3 Carnot heat engines arrangement in series. Now, let me write the work formula for the each cycle, each heat engine. Work for the first heat engine equal to Q1 minus Q2. Similarly, work for the second heat engine equal to Q2. Look at that. Work for the second heat engine Q2 minus Q3. Q2 minus Q3. Similarly, work for the third heat engine. Work for third heat engine. work for the third heat engine is Q3 minus Q4. Q3 minus Q4. But as you know, heat is proportional to temperature. For any Carnot heat engine, heat is proportional to temperature. Heat is proportional to temperature. Work is difference between the heat transfer. Therefore, work also proportional to temperature. Then I can write like this. 1 minute. Here W1 is to W2 is to W3 is equal to W1 equal to Q1 minus Q2 is W2 Q2 minus Q3 minus Q3 is Q3 minus Q4. But heat transfer is proportional to temperature. Therefore, the same I can write as, why I am writing in this way is, here it is clearly given, work ratio from the first engine to third engine 5:4:3. That means W1 is to W2 is to W3 is equal to 5:4:3. Okay. Here W1 is to W2 is W3, 5:4:3 is equal to, since Q is proportional to temperature, I can write as T1 minus T2 is to T2 minus T3 is to T3 minus T4. Now from this, let us take this part, right? W1 is W2. That means 5:4 is equal to T1 minus T2 is to T2 minus T3. It can be also written as 5/4 equal to T1 minus T2 divided by T2 minus T3, or 5/4 equal to T1. Look at the T1 value. T1 is 1000 Kelvin. Listen carefully. 1000 minus T2 divided by T2 minus T3. Let this is the equation number 1. Equation 1. Similarly, let us write for the W2 to W2 is W3, that is 4:3. 4:3 is equal to T2 minus T3 is to T3 minus T4. Here T4 is the last temperature, 300 Kelvin. Therefore, I can write that 4/3 equal to T2 minus T3 divided by T3 minus T4. 4/3 is equal to T2 minus T3 divided by T3 minus T4 is 300. Let this is the equation number 2. Now compare the 1 and 2. From the 1 and 2, unknown values are T2 and T3. We have the two equations. From the two equations, two unknown values, namely T2 and T3, can be decided. From equations 1 and 2, means you solve the equation 1 and equation 2 for getting the T2 and T3. My calculator has shown T2 equal to 708.33. 708.33. Simplify it. And T3 equal to 475 Kelvin. 475 Kelvin. So those are the intermediate source temperatures. Look at the options. Look at the option A itself, 708 and 475. Therefore, option A itself is absolutely correct. I hope all of you clearly understood. It is easy only, but quite lengthy problem. Understood or not? Yes. Dear students, look at the another problem asked for refrigeration system like this. An R12 refrigeration system works between pressure limits of 1.83 bar and 9.63 bar respectively. The refrigeration system is operating between these two pressure limits. Okay. The heat transfer from the condenser is found to be 72 kilojoules per minute. As you know, in the condenser, refrigerant is rejecting the heat. That rejecting heat is 72 kilojoules in 1 minute. The refrigerant vapor leaves the evaporator in the saturated state. That means refrigerant is leaving from the evaporator in saturated vapor state, enthalpy given, corresponding enthalpy, and condensate leaves the condenser is just saturated liquid with corresponding enthalpy 74.6. That means refrigerant is leaving from the condenser as a saturated liquid, whereas refrigerant is leaving from the evaporator as a saturated vapor. The refrigerant flow rate through the system is found to be, the mass flow rate of refrigerant is given 0.5 kg per minute. The COP of the unit is, you are asked to decide the COP of the system. Okay. For that, it is better to mark the pressure versus enthalpy diagram for vapor compression refrigeration system. Pressure versus enthalpy coordinate system. Let me mark the two pressure limits first. The pressure before compression is P1, pressure before compression P1, and pressure after compression is P2. Next, the saturation dome with pH coordinate system. This is the saturation dome, that is the saturation dome. 1 minute. The saturation dome with pH coordinate system is looking like this. 1 minute. Okay, again I need to redraw it. It is like this, something like this. Now, it is clearly given that refrigerant is leaving from the evaporator as a saturated vapor state. This is the state 1. At that state, enthalpy is H1. That H1 is given, the refrigerant vapor leaves the evaporator in the saturated state with H1. This is the H1. H1 equal to 181 kilojoules per kilogram. Next, you know 122 is the isentropic compression. This may be, that curve should not be go inside. Should be very careful. This may be the isentropic compression process. After compression, the enthalpy is H2. Then refrigerant is entering into condenser for dumping the heat. Because of the heat dumping, superheated refrigerant is becoming saturated liquid refrigerant. So this is the state 3. At that state 3, the saturated liquid refrigerant enthalpy given, that is H3. H3 equal 74.6 kilojoules per kilogram. And throttling process is a highly irreversible process maintaining constant enthalpy. The irreversible process must be drawn by broken line or discontinuous line. This is the throttling process representation. It must be drawn by broken line. 3 to 4 throttling process where H4 equal to H3. That means this H3 and H4 both are equal. 3 to 4 is throttling process or isenthalpic process. 4 to 1 is evaporation. Okay. Then it is given mass flow rate of refrigerant 0.5 kg per minute. Mass flow rate of refrigerant is 0.5 kilograms per minute. How much amount of heat is rejected in the condenser? 72 kilojoules per minute. The amount of heat rejected in the condenser, equal to 72 kilojoules in 1 minute. Okay. Then we are asked to decide the COP. For finding the COP, right, I need to know the both refrigeration effect and work input to the compressor. For that, first let us take the here heat rejection in the condenser given. You can find the refrigeration effect per minute. The refrigeration effect which is in minute is equal to mass flow rate of refrigerant, which is in kg per minute, multiplied by refrigeration effect, which is in kilojoules per kg. Here kg cancelled, finally kilojoules per minute. Here mass flow rate of refrigerant given 0.5, and this refrigeration effect per kg equal to H1 minus H4. It is H1 minus H4. Look at the H1. 181 minus H4. H4 equal to H3, 74.6. You simplify this value for getting refrigeration effect, which is in minute. My calculator has shown 53.2. It is equal to 53.2 kilojoules per minute. Okay. Then, as you know, the work required for compressor is equal to heat rejected minus refrigeration effect. That means heat absorption. Heat rejection is given. How much it is given? 72 minus refrigeration effect per minute is 53.2. Simplify this value for getting the work required for compressor in 1 minute. It is 18.8. It is 18.8 kilojoules per minute. Now the COP. COP of the refrigeration system equal to refrigeration effect dividing by work input to the system. Both must be with the same units. Since work input is there in kilojoules per minute, let us take the refrigeration effect also in kilojoules per minute. Here it is 53.2 dividing by 18.8. Simplify this value for getting the answer. My calculator has shown 2.83. Since it is the COP has no units. COP has no units. Look at the options. 2.83. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Dear students, look at the another problem asked for diesel cycle like this. In a diesel cycle, the compression ratio is 10. Generally, compression ratio marked as RC equal to 10, and cutoff ratio is 3. Cutoff ratio marked as rho equal to 3. If the initial temperature for the cycle is 300 Kelvin, I can mark T1 300 Kelvin. The temperature at the end of the expansion, you are asked to decide what is the temperature after expansion process. For that, it is better to mark the PV diagram for the diesel cycle, pressure versus volume diagram. As you know, diesel cycle consists of 4 processes. The very first process is isentropic compression process. 1 to 2 isentropic compression, followed by 2 to 3 constant pressure heat addition, and 3 to 4 isentropic expansion followed by 4:1 constant volume heat rejection. This is the constant pressure line. It should be a horizontal line. That is the diesel cycle. For this diesel cycle, you are asked to decide temperature after expansion. You know, this is the expansion process. This is the compression process. Temperature after expansion process means T4 is how much? You are asked to decide T4. For that, you know the expansion ratio. As you all know, expansion ratio for diesel cycle equal to compression ratio by cutoff ratio. Compression ratio is 10, cutoff ratio 3, it is 3.33. That is the expansion ratio. Then for the 1:2 process, look at the 1:2 process. 1:2 process is isentropic process. For the process 1:2, where entropy is maintained constant, I can say that T2 equal to T1 into RC, compression ratio power gamma minus 1. It is equal to, look at the T1 value. T1 value equal to 300 into compression ratio given 10 power gamma 1.4 minus 1.4. You simplify this value for getting the T2. My calculator has shown 753.6 Kelvin. That is the temperature after compression. Then as you know, for the 2 to 3 process, pressure is maintained constant. At constant pressure, volume is directly proportional to temperature. That means volume by temperature at state 2 is equal to volume by temperature at state 3. I can say V2 by T2 equal to V3 by T3. From this T3 is equal to T2 into V3 by V2. As you know, volume after heat addition V3 dividing by volume before heat addition V2 at constant pressure, that ratio V3 by V2 is called cutoff ratio. T3 equal to T2 into rho, where rho is the cutoff ratio. Therefore, T3, that is the temperature after heat addition, equal to T2 into rho. Look at the T2. T2 value you got 753.6. 753.6 into rho value. Look at the rho value 3.33. 3.333, something like that. Decide the T3. My calculator has shown approximately 2260 Kelvin. It is not exact value, approximate value. Okay. Then look at the 3 to 4. Since the 3 to 4 process is isentropic process, for isentropic process 3 to 4 is the isentropic process. For that isentropic process, I can write T3 by T4 equal to V4 by V3 power gamma minus 1. As you know, the quantity V4 by V3 is the expansion ratio RE power gamma minus 1. Then T4 equal to T3 dividing by expansion ratio power gamma minus 1. Look at the T3, 2260 dividing by expansion ratio. Look at the expansion ratio 3.33. 2.1 minute. This is the rho value, na? Rho value 1 minute. Rho value given 3, not 3.33. 1 minute, sorry. This is the rho. Right here it is rho only. This rho equal to 3 only. 3 only, not 3.33. Confused, right? So with that you are getting this value same only. RE value is 3.33. 3.33 power 0.4. Simplify it for getting your answer. T4, my calculator has shown 1396 Kelvin. 1396 Kelvin. Look at the options. 1396 Kelvin. Option C is absolutely correct. Very simple. Understood clearly? Yes. Dear students, look at the another problem asked for thermal power plant like this. Steam at 20 bar and 360 degrees centigrade. Corresponding to this pressure and temperature, enthalpy given, entropy also given. Let this is the H1, S1. Is expanded in the turbine to 0.08 bar. Pressure before expansion is 20 bar. Temperature given. Definitely the given temperature is superheated temperature because the steam is generally allowed for the turbine in superheated state. After expansion, pressure is given. Corresponding to this pressure, entropy of the saturated liquid given, entropy during the phase change process given, enthalpy of the saturated liquid given, and enthalpy during the phase change given. The wet steam becomes saturated liquid in the condenser. That means, though the superheated steam is allowed for the turbine, that superheated steam is becoming wet steam. That wet steam during the condensation process is becoming saturated liquid. And then pumped back to boiler, given the pump work is 2 kilojoules per kilogram. For that, now it is better to mark the TS diagram, temperature versus entropy diagram. With the temperature versus entropy diagram, the saturation dome is appearing like this. Okay? As you know, the Rankine cycle is having only two pressure limits, that is boiler pressure. Boiler pressure is the P1, that is the pressure of the steam at the beginning of the expansion in the turbine. This is the P2. That P2 itself is the condensation pressure. P2 equal to condenser pressure. It is clearly given that during the expansion process, superheated steam is becoming wet steam. That wet steam is becoming saturated liquid. And during the pumping process, pumping is for boosting the pressure. Right? But during the pumping process, what is happening? Pressure is increasing. This is the 3 to 4. The saturated liquid is left to subcooled liquid during the pumping process. This subcooled liquid is entering to boiler, where the subcooled liquid is becoming saturated liquid. Saturated liquid is becoming saturated vapor. Saturated vapor finally becoming superheated vapor. That superheated vapor is allowed to the turbine. Anyhow, corresponding to P1 and temperature T1, H1 given, S1 given. Let me write that value. Here H1 equal to 3159 with respect to units, and S1 given 6.99 with respect to units. After expansion, the steam is available in wet state. That wet steam properties at state 2, it is SF2. That SF2 given 0.593 with respect to units, and SFG2 also given. Look at that value, SFG2, where it is given 7.636, 7.636, and HF value given, that is HF2. Of course, HF2 equal to HF3 only, because pressure remains same during the 2 to 3 process, 174, and the amount of latent heat dumping 2403. HFG3, HFG2, I can say HFG2, HFG2. how much it is given? 2403. 2403 with respect to units, kilojoules per kg. Remember here P1 is the boiler pressure and P2 be the condensation pressure. We are asked to decide the specific steam consumption and thermal efficiency. For that we need to decide the quality of the steam after expansion, that is X2. For that, what is remaining constant during the steam expansion process in the turbine? Entropy. 1 to 2 is isentropic process. 1 to 2 isentropic expansion process. For this expansion process, I can write that S1 equal to S2. But look at the state 2 is lying in the wet state. Therefore, that S2 I can write as S wet 2. S1 equal to S wet 2 equal to what? SF2 plus X2 SFG2. Look at the S1 value 6.99 equal to SF2 0.593 plus X2 value into SFG2 directly given. SFG 7 point, where it is 7.636. From this, the unknown value is X2. Decide the X2 value. My calculator has shown the X2 value 0.84. 0.84. After deciding the X2, enthalpy of the steam at state 2 equal to H wet 2. That H wet 2 equal to HF2 plus X2 into HFG2. Are you following? Yes. Look at the HF2. HF2 174. X2 value got it 0.84. HFG2 2403. 2403. Simplify it for getting the value 2190.5 approximately 2190.5 in kilojoules per kilogram. Okay, that is the H2. By using that H2, I can decide the turbine work. Turbine work equal to, turbine is the steady flow device working by reversible adiabatically. Reversible adiabatic steady flow work always equal to change in enthalpy. That means turbine work equal to enthalpy drop of the steam. H1 minus H2. Look at the H1 3159. 3159 minus H2. Look at the H2 2190.5. 2190.5. Simplify this value for getting turbine work. 966.5 kilojoules per kilogram. That is the turbine work. Okay. Then I can also decide the network. Network equal to what? Turbine work minus pumping work. Turbine work is 966.5 minus pumping work given very less, that is 2. 2 is equal to 964.5 kilojoules per kilogram. Okay. Then what is the specific steam consumption? Specific steam consumption equal to 3600 divided by network output. Network output 3600 divided by 964.5. Simplify this value. My calculator has shown 3.73. That is the specific steam consumption in kilogram per kilowatt hour. Kg per kilowatt. 3.73 kg per kilowatt hour. Option A. Then you need to decide thermal efficiency. For deciding thermal efficiency, I need to find the heat input, because thermal efficiency equal to net work output by heat input. Your heat input is what? Heat supply to boiler. Heat supply to boiler equal to steam enthalpy at the exit of the boiler minus steam enthalpy at the inlet of the boiler. Steam enthalpy at the inlet of the boiler is H4. That H4 I can write as H3 plus pump work. Okay, right? H3 is nothing but saturated liquid enthalpy. That saturated liquid enthalpy, this H3 equal to HF2 only. This itself is the H3. This H3 equal to HF corresponding to condensation pressure. That is given as 174. 174 plus pump work is 2. That is 176. It is in kilojoules per kilogram. That is the H4. Then H1 minus H4, enthalpy of the steam at this state minus enthalpy of the steam at that state is the heat supplied. Heat supplied equal to H1 minus H4. Heat supplied to boiler is equal to H1 minus H4. Look at the H1. Look at the H1. This is the H1. 3159 minus H4. H4 176. Simplify it for getting the heat supplied. My calculator has shown 2983. 2983. 2983 kilojoules per 2983 kilojoules per kilogram. Then thermal efficiency. Thermal efficiency equal to ratio between the net work output and heat supplied into 100. Net work output 964.5. 964.5 divided by heat supplied 2983. 2983 into 100 for getting the efficiency 32.33. 32.33. Look at the efficiency 32.33. A and D correct. It is MSQ type question. A and D correct. Easy question only. Easy problem only, but lengthy problem. You should know the concept of thermal power plant. I hope all of you clearly understood. Understood or not? Yes. Thank you.
Welcome to ACE Online and ACE Engineering Academy. Myself Madhushekar, faculty at ACE Online and ACE Academy. I am here going to discuss about the pre-GATE 2026 mechanical production and material science questions I am going to discuss. Now, here is a question from the material science. The steel contains 0.4 weight% carbon with no other alloying elements is cooled from liquid state to just below eutectoid temperature, 728 degrees Celsius. The percentage of perlite is Now listen carefully. If you see the diagram, let us consider the diagram. Iron cementite phase diagram I am considering. In iron cementite phase diagram, okay, this is the eutectoid temperature line. Okay, listen carefully. This is the eutectoid temperature line, that is 728 degrees Celsius. Corresponding to this, the percentage of carbon here it is 0.8% of carbon. Here the percentage of carbon here it is nearly 0.025% of carbon. See, sometimes in the GATE exam, they usually give the diagram, sometimes they will not give. That's why here in this question, I did not give the diagram. So you should remember the values. At least you should remember 0.025, 0.8, 6.7. You should remember these values. Now, what they are asking, percentage of perlite they are asking. Percentage of perlite. So remember, the perlite is a microconstituent. At which point they are asking 0.4 weight% of carbon with no other alloying elements is cooled from liquid state. Suppose you just assume this is a liquid state or some other point. If we cool from liquid state at just below the eutectoid temperature, means at this point 0.4 weight% of carbon point, and just below that eutectoid temperature they are asking calculate mass fraction of perlite and proeutectoids. They are asking only perlite, but in this region we are having proeutectoid cementite, proeutectoid ferrite, proeutectoid alpha plus perlite. We are having both, right? So 100% of perlite will get here. So I'll take this is the Cp. 100% of alpha I'll get here. This is I'll take it as a alpha. So this will be the liver line for our question. This is the liver line. So the liver line, if I consider here, left side is alpha, right side is perlite. Okay. Here perlite, it is 0.8% of carbon. Alpha here it is 0.025% of carbon. C naught, that is 0.4% of carbon. 0.4, 0.8, 0.025. Now mass fraction of perlite. So mass fraction of perlite, how will you get? The mass fraction of perlite, how will you get? By using this liver line. So I'll take opposite half of the line, that is C naught minus C alpha by C perlite minus C alpha. Okay. C naught is 0.4 minus C alpha is 0.025 by Cp is 0.8 minus 0.025. So from this, by solving this equation, you will get the mass fraction. See, I am using the GATE calculator here to solve this question. Okay. Now 0.4 minus 0.025 divided by 0.8 minus 0.025. So I'll get 0.4838. See, this is a mass fraction, but they are asking percentage of perlite. So percentage means 48.38%. So 48.38% is the correct answer for this question. 48.38. Now, next question here it is. See, a cylindrical tensile test specimen shows a uniform elongation of 30%. Uniform elongation of 30% before necking. The engineering stress at the onset of necking point is 480 megapascal. See, they are giving the details at the necking point. So, elongation, remember, elongation is nothing but delta L by L into 100. That is 0.3. Right? And ultimate tensile stress, sigma ut, that is nothing but engineering stress is given 430 megapascal. Engineering stress is given 430 megapascal. So material characteristic equation they are asking in the plastic region. So that means what they are asking, suppose if I consider the stress strain curve of a material, if I consider the stress strain curve of a material, the stress strain curve is like this. So they are asking to calculate they are asking to find the equation of this region, in this plastic region. What is the equation? So this equation is a parabolic equation. Now, generally, what is that equation? Sigma t is equal to, okay, k into epsilon t power n. So the given data that is at necking point, the given data that is at necking point, the given data this is at necking point. So at necking point, at necking point, okay, epsilon T equal to N, right? How will you calculate epsilon T from engineering strain? That is ln 1 plus epsilon E, right? That is equal to ln 1 plus epsilon E is 0.3. What is the answer? What is the answer for this? ln 1.3. That is 0.26, 0.262. So you just cross check. Sometimes you can eliminate here. So epsilon T equal to N. So N value here 0.3. So this is not correct. Here also N value 0.3. So this is not correct. So there may be a chance of this one or this one. So that we should calculate K and also. Now next is calculate sigma T from sigma E. Sigma T is equal to sigma E into 1 plus epsilon E. That is sigma E is 430 into 1 plus epsilon E is 0.3. So 430 into 1.3. So that here 430 into 1.3. So you'll get 559. You'll get 559. 430. Okay, now 480 now. Sorry. This is 480, not 430. 480. 480 into 1.3. 1.3, that is 624. 624 megapascal. So 624 megapascal is a true stress, not K value, but here is given. So this is not correct. So answer is this. So how to calculate K value from this? I'll substitute the sigma T, epsilon T N in this equation. So 624 is equal to K into epsilon T 0.262 power 0.262. By solving this, you will get a K value. I will get nearly 886 megapascal. So from this, you can say the power law equation sigma T is equal to 886 into epsilon T power 0.262. This is the answer. I hope you understood. Okay. So this concept is very, very important for exam. Okay, no? This concept is very, very important for exam. Now, let us consider another question. A steel specimen shows 50 HRC. 50 HRC means Rockwell hardness. Rockwell hardness scale C. Okay, now 50 HRC means they are saying hardness number 50. From the quenched end in a Jomini test, if another steel shows 50 HRC at 20 mm from the quenched end. Now, listen carefully. Let us consider two specimens, two steel specimens. Remember, this is one steel specimen and this is another steel specimen, two steel specimens. Okay, both are of same length, and we quenched in water. Otherwise, by using a Jomini test, we sprayed with water. Here we sprayed with water. Here also we sprayed with water, like that. The first specimen and second specimen, if I take up to 5 mm, this is, let us say 5 mm, 50 HRC it has, 50 Rockwell hardness number. But second specimen up to 20 mm, it has, remember, up to 20 mm, it has 50 HRC. Okay, this is only 50 HRC up to 5 mm, this is 20. So tell me, from the quenched end, then compared to the first steel, the second steel has, tell me which is having more depth of hardenability. The second one is having more depth of hardenability because 20 mm it is giving, it's only 5 mm. So second steel has higher depth of hardenability compared to the first one. Higher depth of hardenability compared to the first one. So B is the correct answer for this question. B is the correct answer for this question. Now, a sheet of thickness 3 mm, okay, width 150 mm is V bent using a die opening of 24 mm. Yield strength of material is 250 megapascal. Assume die shape factor is 1.33, the bending force. It is a straightforward formula based question. In the question, what is the given data? Thickness is given 3 mm. Okay. Width is given 150 mm. That we can say a length of a bend, you can say. Okay. Die opening W, this is actually W, width of die opening, width of die opening that is given 24 mm. This is length of bend actually. 150 mm is length of bend. Okay. And assume the die shape factor K is equal to 1.33. Then bending force is equal to bending force. Formula is what? Actually die shape factor into, okay, sigma y or sigma u into L into T square by omega, T square by width of die opening. This is the formula. Very simple. Once if you know this formula, you will get the answer easily. That is, bending force is equal to die shape factor 1.33 and yield strength or ultimate strength is 250. This is 150, length of bend, thickness is 3 whole square by 24, right? And use calculator here. Use calculator. So here I am using 250 into 150 into 1.33, sorry, 1.33 into 9 divided by 24. You'll get 1.87 into 10 power 4 newtons. So that you can say 18.7 into 10 power 3 newtons. So 18.7 kilo newtons. So 18.7 is only for A option. So that you'll get the answer easily. So this is straightforward formula based question actually from sheet metal operation. This is from sheet metal operation. Right. Now here is a question from the metal cutting. In a turning operation, increasing the cutting speed V by a factor of 4 results in a reduction in tool life T to 1/16th of its original value. The value of N in Taylor's tool life equation. See, it's a very simple question. From the Taylor's tool life equation, you will get the answer here. What is the Taylor's tool life equation? Taylor's tool life equation. Vt power n equal to constant. Taylor's tool life equation is equal to Vt power n equal to constant. So I can write V1 T1 power n is equal to V2 T2 power n. As per this question, see, cutting speed increased by a factor. See, V2 is equal to 4 times of V1. Cutting speed increased by 4 times of initial speed. Because of increasing cutting speed, tool life is going to reduce. So tool life is reduced by 1/16th. Tool life is reduced by 1/16th. I am using these two data. See, V1 T1 power n is equal to 4V1 into T1 by 16 whole power n. So here V1 T1 power n is going to cancel. So 1 is equal to 4 into 1 by 16th power n. Okay, 16th power n. So you can bring this into this side. Otherwise, you can bring this side. Okay, now 16 power n is equal to 4. So here 4 square is 16. So 4 into 2 power n equal to 4. So 2 power n equal to 1, n equal to 1 by 2. So here C is the correct answer for this question. Simple question it is, right? Now, the next question here it is, the following abrasive equations are available for achieving different surface finishes. So, different methods we are using, different abrasive methods we are using for surface finishing. They are horning, super finishing, lapping and buffing. Which of the above surface finishing processes is the correct sequence reflecting the order from highest precision to the lowest precision? See, out of all these 4 abrasive methods, the highest super finishing operation is super finishing. The highest precision, very high precision you will get. And the least one is buffing. Least one is buffing. Buffing is only for polishing. Remember, buffing is for polishing. This is highest super finishing. Highest precision you will get. Okay. Now, you just check it. Out of all these 4, super finishing highest first, buffing is last. So, C is the correct option. So, C is the correct option for this question. Here is a metal cutting question. It is somewhat lengthy. You see here. The following data from an orthogonal cutting test are available. See, in this question, the given data, rake angle alpha is given 15 degrees. Okay. And chip thickness ratio R is equal to 0.383 given. Then uncut chip thickness is given, T is equal to 0.5 mm. Uncut chip thickness T is equal to 0.5 mm. And width of cut is given W, that is 3 mm. And shear yield stress of the material is 280. Okay, tau is given, shear yield stress tau 280 Newton per mm square. Average coefficient of friction of the tool face is given mu 0.7. So here shear angle is not given. So I am going to calculate shear angle. So tan pi is equal to R cos alpha. Remember, R cos alpha by 1 minus R sin alpha. Tan pi is equal to R cos alpha by 1 minus R sin alpha. So, R is equal to 0.383 cos 15 degrees by 1 minus 0.383 sin 15 degrees, right. So, from this alpha value, tan pi value, otherwise I will take it as a pi value, shear angle I am taking directly. Shear angle value is 22.32 degrees. Then I want friction angle also, so that tan beta is equal to mu, that is 0.7. So, beta is equal to friction angle, okay na, friction angle, that beta is equal to friction angle is equal to 35 degrees. Beta is equal to friction angle is equal to 35 degrees. Right. Now, I have rake angle alpha, shear angle beta and shear angle pi and friction angle beta. Now, from that I am going to calculate the cutting force. cutting force formula you should remember for exam. Cutting force formula is tau W into T, tau W into T into secant beta minus alpha, secant beta minus alpha into cos pi plus beta minus alpha into sin pi. This is the cutting force equation. Okay, this is the cutting force equation, and by solving this equation you will get the force. Now the data I am substituting here. Now tau is equal to 280 into width is 3 into uncut chip thickness is 0.5, uncut chip thickness is 0.5 divided by, okay, and directly I am writing these values, secant beta minus alpha, otherwise I will write secant beta is 35 minus alpha is 15 degrees into cos pi is 22.32 plus beta is 35 minus 15 into sin 22.32, right. This is the equation. By solving this equation, you will get the force 1405.7 Newton. So here the cutting force 1405.7, directly you will get the answer B. B is the correct answer for this question, because cutting force we are getting from this equation. Now next is the shear force, tangential force or thrust force. Thrust force they are asking. So thrust force Fc is equal to, Ft is equal to Fc cos alpha, Fc tan alpha plus the small mistake here. The thrust force direct formula is not there. In terms of friction, we should calculate the friction mu equal to Fc tan alpha plus Ft by Fc minus Ft tan alpha. This is the formula, and we know mu value is 0.7 and Fc value is 1405.7 tan 15 degrees plus Ft by Fc 1405.7 minus Ft into tan 15 degrees. Right. By solving this, you will get Ft, that is equal to 511.3 newtons you will get. So 511.3 newtons you will get. So here is the question. You should remember for exam point of view this equation and this equation. Right. Here is a question from the slab milling. In a slab milling operation, a cutter of 270 mm diameter, okay, this is a diameter D with 15 teeth. So the number of teeth here is given, 15 teeth, on it is used. If the depth of cut is 4 mm, depth of cut D is given 4 mm, and table feed is 210, okay, mm per minute, and cutting speed is given, cutting velocity or cutting speed 60 meter per minute. Then maximum chip thickness in milling. See, they are asking the maximum chip thickness in milling. So maximum chip thickness formula you should remember for exam, that is 2Fm by Nz, 2Fm by Nz under root small d by capital D. This is the formula. Once is also a formula based question. If you remember this formula, you will get. But in this formula, n value is not given. Speed RPM value is not given. So that's why I am using velocity v is equal to pi dn by 1000 because diameter is in mm. So that pi dn by 1000 I am using. So from this n is equal to 1000 into velocity is 60 meter per minute into pi into 270. From this you will get 70.735 rpm n value. So if I substitute this equation in this, 2 into feed is given 210, speed is given 70.735 into number of teeth 15 is given into small d is 4, capital D is 270. By solving this, you will get the answer, that is 0.0482 mm. 0.0482 mm. So B is the correct answer.
So you can find one question from simplex method. In this question is a simple question only. Maybe it is like a initial solution mentioned clearly. Initial solution mentioned, and which is the entering variable. The entering variable is most negative element is going to be entering variable. What is the most negative element here? -3, -5, -9. -9 is the most negative element. So x3 is going to be entering variable. In case of maximization, in the Z row, most negative element is entering variable, and leaving variable ratio we can take. What is the ratio? Ratio is equal to RHS to the key column coefficient. Which is the key column here? X3 column is the key column. Take the ratio. 24 divided by -1, -24. 18 divided by 0, infinity. 36 divided by -2, -18. What is being observed? Least positive ratio is a leaving variable. There is no least positive ratio. Here we can see no least positive ratio. No least positive ratio, that implies no least positive ratio, that implies no leaving variable. No leaving variable means this solution leads to unbounded solution. If there is no leaving variable, the solution is said to be unbounded. So what is the answer here? Option D, unbounded solution. So coming to next question. In a single server queuing model, mean arrival rate 12 per hour, lambda is equal to 12 per hour, and mean service rate should be kept in this manner only, per hour only you have to keep. What about the mean service rate? Mean service time is 4 minutes. Mean service rate was not given. Mean service time is given. So how about mu value? Mu is equal to 1 divided by 4 into 60, because our unit should be per hour. It is equal to 15 per hour we are going to get. After having lambda and mu, then you can find out rho, lambda by mu, it is equal to 12 by 15. You can keep aside. Now look at the question. Expected waiting time in the queue. Expected waiting time in the queue means WQ you have to find out. So for finding WQ, so what we do? WQ is basically rho into WS. So what is WS? WS is equal to LS by lambda. LS is equal to rho divided by 1 minus rho. You can do reverse. Get the LS value first. So first you find out LS. LS is equal to rho divided by 1 minus rho. 12 by 15 divided by 1 minus 12 by 15. How much it is? 12 by 3, 4. LS is equal to 4. And come into WS. WS is equal to LS by lambda. What is LS value? 4 divided by 12. 4 by 12. WQ is equal to rho into WS. Rho value 12 by 15 into 4 by 12. 12 get cancelled. It is equal to 4 by 15. So 4 by 15 means 4 divided by 15. 0.26 into 60. 16 minutes. Answer is 16 minutes. Since it is multiple choice, right? So where you can find this? Option C, 16 minutes is the answer. So coming to next question. So this question from CPM network. So we have to find out free float and independent float of, free float of C, independent float of F are respectively. So we have two types of diagrams, AON diagram and AOA diagram. Here we have to use only activity and arrow diagram, that is AOA diagram. You cannot use AON. So please plan for that. And what about diagram for this? A, B, C have no condition. So start with a circle, A, B, C. So 3 lines you can take. A duration 5, B duration 4, C duration 10. D after A, D can be taken. E after AB. So there is a need of dummy towards A side or B side, where you are going to keep dummy towards B side. So this is AB. From here, which one you can take? E. E15, D8. F after C. After C, F can be taken. What is the duration of F? 3. G after D comma E. So D, E, both you can merge, right? Both you can merge. So that we are going to start which activity? G. Duration is equal to 6. H after C. After C, where is C? C is here. H. I after D, E, F. So D, E already used. So we can use again dummy activity towards F side. From here, which one you can take? I you can take. I duration how much? 12. That's all. Diagram is over. So whatever lines left over, you can merge in the final circle, because dangling is avoided always. This is a diagram. You can verify diagram. A, B, C, no conditions. D before A, yes, right. E before AB, F before C, G before DE, fine. H before C, excellent. I before DEF, DEF, I before. So DE here, DEF here, and finally we can have a one circle, and even numbers we can keep 1, 2, 3, 4, Fulkerson's rule, 5, 6, 7, tail number less, head number high. Get the critical path by observation. First you mark the critical path, the easy calculation. What is critical path in this? Suppose if you take this 10 plus 3, 13, 13 plus 12, we are getting here 13, 13 plus 2, 15, 60, 25 only. And if you move this 5 plus 15, 20, 26. Next 5 plus 15, 20, 20 plus 12, 37. And H value also you can keep. H value 10. So critical path is A, dotted arrow, E, dotted arrow, I. This is critical path. B, E, I, and along the critical path get the values. 0, 0, 5, 5. This one is 5, 5, 20, 20. This is also 20, 20, 32, 32. And the fourth event, we can make use of forward pass and backward pass. So 0 plus 10, 10, backward pass. 20 minus 3, 17. 32 minus 10, 22. So minimum is 17. Our interest activity C, activity F. Activity C you can take out. Activity C. Activity C 1 to 4. C duration 10. 0, 0, 10, 17. So get the first total float. Total float is equal to 17 minus 0 minus 10, 7. And come into free float. The question is free float. So free float is equal to total float minus slacked head event. 0. So free float is equal to 0. Where you can find this? Option A, option B, both are having zeros, right? Now I can remove option C, option D. Answer could be either A or B. Next, independent float of F. F also we can take out. Activity F. Activity F. So F 4 to 6. F duration 3. 10-17. 20-20. Get the total float first. Total float is equal to 20 minus 10 minus 3. So 7. Free float is equal to 7 minus 20 minus 20, 7. Independent float is our requirement. Independent float is equal to 7 minus 17 minus 10, 0. Independent float is equal to 0. So what is the answer? 0, 0. Now straight away I can take option A. Option B deleted. Only answer is option A. Next question from inventory control. A manufacturing company requires bearing in its product assembly, and these bearings can be produced in the same plant at the rate of 100 bearings per day. So K was given. It is a production model. K is equal to 100 per day. The annual requirement of bearings is found to be 12,000 units. So capital D is equal to 12,000 units. 12,000 units per year. Number of working days 300. Number of working days 300 means we can find out daily demand. 12,000 divided by 300. So 2 zeros cancel, no? So it is equal to 40 per day. So daily consumption will become 40. The annual inventory holding cost is 20 per bearing. So CC was given. CC is equal to 20 per unit per year. Inventory holding cost. Each setup cost is equal to 2000. C naught is equal to 2000 per setup. Next, if the inventory cost is to be minimized, the maximum inventory Qmax is equal to generally EBS. Why should we use EBS? Because they mentioned inventory cost is to be minimized. EBS into K minus D by K. This is a formula for Qmax. So what is unknown to us? K is available, D is available, K also available, EBS only not available. So use a formula. What is the formula for EBS? EBS is equal to under root 2D C naught by CC into K divided by K minus D under root. Just substitute 2 into 12,000 into C naught. C naught how much? 2000 divided by CC 20, 100 divided by 100 minus 40. If you simplify this, how much it is? 2 into 12,000 into 2000 divided by 20 under root. It is equal to 1549. You are going to get here 1549.19 into 100 divided by 60 under root 1.29. If you multiply this 1549.19, it is equal to 2000. Units is not answer. EBS value 2000 units, and you can substitute here. Qmax is equal to EBS into K minus D by K, 2000 into 100 minus 40 divided by K value 100. It is equal to 1199 units. So it is around 1200 units. 1199.99 something you are getting. So what is the answer here? Next integer mentioned. So 1200 units is the answer. So this is regarding the solutions for pre-GATE, and I wish you all the best for GATE 2026.